Hello everyone, welcome back to my channel Genalytiq. If you want to learn data analysis using Python, then Pandas is one of the most important libraries you should learn. Pandas is a Python library used for data analysis, cleaning, and manipulation. In this full course, we have covered Pandas step by step from beginner to advanced level with multiple examples. We will start with Module 1, Introduction to Pandas. Here we understand what Panda is and why it is used. Module 2, Core Data Structure. We learned series and DataFrame, which are the foundation of Pandas. Module 3, Data Inspection and Exploration. We explored how to understand and analyze a dataset. Module 4, Reading and Writing Data. We learned how to load and save data from CSV, Excel, and JSON files. Module 5, Data Cleaning. We handle missing values, duplicates, and messy data. Module 6, Data Selection and Filtering. We selected specific data and filtered rows based on condition. Module 7, Data Manipulation. We created new columns, updated values, and sorted data. Module 8, Combining Data. We combined multiple datasets using merge, concat, and join. Module 9, Group by and Aggregation. We extracted useful insights from grouping and calculation. Module 10, Data Reshaping. We learned pivot and meld to change the structure of data. Module 11, Date and Time Handling. We worked with date time data and performed time-based operation. So, whether you are a beginner or already know a little Pandas, this course will help you to build a strong foundation. Now, let's get started and learn Pandas step by step. So, our library name is Pandas. Okay. So, Pandas is the Python library that used to work with data. That means data. Okay. Or you can call data set. Okay. So, whenever you need to work with huge data set, then always you have to use Pandas. Okay. So, basically, Pandas is required to use in data analysis. Okay. Data cleaning or data manipulation. Okay, so this type of work happens using Pandas. So if you are working as a data scientist or data analyst or business analyst or uh, machine learning domain, wherever it is, so everywhere you need to work with data, right? You need to work with data. So always you have to use Pandas. Whenever you are working with data, you have to use Pandas. Okay. So Pandas basically help us to work with table-like data. Okay, table-like data. Because Pandas always work with structured data. Okay. Pandas always works with structured data. That structured data means just like table. Just like table. Those are having rows and column. So whenever you working in any industry, then you have to work with some CSV file or Excel file or SQL, okay, MySQL or API. Okay, this type of data you need to work with. Okay, so all are structured. All are structured data. All are classified as structured data. Okay, so whenever you are working with CSV, Excel, API, anything, all are classified as structured data. Okay, that is why we say Pandas actually works with table-like data. Okay, Pandas always work with table-like data. So why do you need to use Pandas? Okay, so basically Pandas help us to analyze large data set. Okay, it help us to clean messy data, right? In industry, whenever you get any kind of data from any source, okay, from any source, most of the time all the data are messy. So you have to clean that messy data, okay, before processing, okay. So for that you have to use Pandas. Now third one is it reduce manual coding, okay, manual coding. It basically help us to perform different type of operation, okay, different type of operation like filtering, okay, filtering, then sorting our data, grouping our data, okay. This type of operation performed by our Pandas, okay. So we use Pandas because it makes working with data very easy, okay. And instead of writing a long code, you can do complex operation in just one line of code, okay. That is why we need to use Pandas whenever we need to work with data set, basically large data set, okay, large data set, fine. So guys, first of all, I'm creating my GitHub repository for this tutorial, okay. So I'm just giving name as Pandas tutorial, okay. Now this public, I'm adding readme file, Python, and my license MIT, okay. Now I'm creating my repository, so my repository gets created. Now I have to copy my URL, okay. So this is my local system where I'm going to clone my repository, okay. So in order to clone my repository, I have to open my terminal and we have to write git clone and I have to paste my URL and now enter. See, my repository gets cloned over here, okay. Now this is my project folder. Here I'm going to write all my code, okay. So I have to open my VS Code. So my VS Code gets open. Now, before we start our project, always we have to create our environment, virtual environment, right? So in order to create my virtual environment, we have to open our terminal and then I am opening my command prompt. Now you have to write Python -m venv and you have to provide your virtual environment name, okay. So I am giving as venv. See guys, if only one version of Python is installed in your system, then you have to write like this, okay. But suppose you have multiple version installed in your system, okay. In that case, you have to write like this: py space minus, you have to provide your version name. Suppose I need to use 3.13 because multiple version is installed in my system. So I want to use 3.13 version. So for that I have to write py space minus 3.13, then rest are saved -m venv and you have to provide your virtual environment name, okay. Suppose my env, I am giving name as my env. Now I have to press enter. Now it will create a virtual environment for my project, okay. Now see, my virtual environment gets created. Now I have to activate my environment first. So for that I have to write -env /script /activate my virtual environment name /script /activate. Then you have to press enter. Now see, my virtual environment gets activated, okay. Now in order to use Pandas, you have to install Pandas library in your system first, okay. So in order to install your Pandas, you have to write pip install Pandas and you have to press enter. Now if Pandas is not installed in your system, then it will install like this, okay. So basically Panda is getting installed in your virtual environment, okay. Now my Pandas library get installed in my virtual environment. So now I can use Pandas, okay. So let me close all these things. Now see guys, one more thing that I need to mention over here. In this project, I'm not going to use .py file, that means Python file, okay. I'm going to use .ipynb file, that means Jupyter Notebook file. See why? I tell you why. Because Pandas means we need to work with data, right? We need to work with data set. So whenever you working with data set, then you have to read your data, you have to understand your data properly, you have to manipulate your data, right? So Jupyter Notebook allow us to run our code step by step, which makes data analysis much easier and more interactive. Okay. And the second important thing is, whenever you execute your code, you get the output just below of your code. Okay, just below of your code, just like a table. So basically data set is a just like a table. So if you get your output as a table, okay, then it will be very easy for you to read your data, to understand your data. Okay, that is why it is always recommended, whether you are working for your own project or you are working in industry, whenever you get your data, to understand your data, to read your data, to manipulate your data, to clean your data, always you have to use Jupyter Notebook first. So once you understand your data properly, then you have to move to Python file for production level code automation and building your application properly. Okay, so in production grade you have to use Python file always, but in order to understand your data first, you have to use Jupyter Notebook. It is always recommended. Okay, so you can use Jupyter Notebook in different way. Either you can use Google Colab, okay, or if you have you are using Conda, in your system, then you can use Jupyter Notebook application directly. Or if you want to use Jupyter Notebook in VS Code, then you have to install one extension. Okay, you have to use one extension. You have to install, that is Jupyter. Just you have to write Jupyter and you will get this extension. As this is already enabled in my system, so I'm getting this disable option. So if you are doing it first time, so you will get enable option. Just enable it. Okay, so once you just install this extension, then to test it, first of all, I'm creating one file. Suppose first.ipynb. See, as my Jupyter extension is installed in my system, so automatically VS Code understand that using this ipynb file extension, or VS Code automatically understand that I'm creating notebook file. Okay, so you get this code option. This is the cell option. Okay, you can create multiple cell like this, and this is a markdown. You can mark down any code. Okay, so before starting, you have to select your kernel first. Okay, you have to select your kernel first. Then you have to use Python environment, and you have to use your virtual environment. That is, this is my virtual environment. Okay, so I have to select this one. Now it gets selected. Now to test, what I have to do, I can write just one simple line, 2 plus 2. Okay, and once I execute, then it will install one another extension, that is IPY kernel file. Okay, I have to install it for once. Now it is IPY kernel is getting installed. Okay, once this IPY kernel will get installed, automatically this cell gets executed. Okay, now see, I'm getting the output as 4. That means my file is ready. Okay, now my file is ready. Now in order to use my Pandas library, we have to import this library, right? So for that we have to write import Pandas as PD. See, as PD is, this is the alias name. Okay, so whenever you need to use your Pandas, you just write PD. You don't need to write Pandas again and again. You can just write PD. So we are giving alias as PD. Okay, this is a naming convention. That's it. Now we have imported our Pandas. Now to check whether my Pandas gets installed or not, we can write print PD dot underscore version. Okay, underscore version. So if it gets give any output, then it is okay. Now see, it is giving me the output as 3.0.2. That means my Panda gets installed in my project. Okay, now I can use my Panda in order to read my data. Okay, now we will discuss about code data structure. Okay, code data structure of Pandas. See, there are two types of code data structure that Pandas has. One is series, okay, and second one is data frame. Okay, one is series, another is data frame. Now first discuss about series. So series is basically one dimensional data structure. Okay, so series is basically one dimensional data structure, just like list or a single column table. Okay, suppose you have student name and marks. Okay, now A, B, C. Okay, and suppose A is having 85, 87, 90, like this. So this is a series. This is a series because it is one dimensional data structure, because it is having only one column. Okay, only one column. Now all the series is having one is value. Okay, this is my value, and another is index. Okay, this one is my index. Okay, so if your data have only value, then automatically index gets assigned with each value. Suppose this is my value 25, 35, 45, only I have this value. Okay, so automatically index gets assigned. So index will start from 0. Okay, 0, 1, 2, 3, 4, like this. Okay, so if your data is only having value, then automatically by default from 0 index will be assigned in each value. Okay, but if you have your own index like this, suppose marks, each student have different marks, and each student is having different name, then this 85 is having this index, that is A. This 87 is having index B. Okay, so if you have index, then you can assign like this, and if you don't have index only value, then automatically index is assigned and index will start from 0. Okay, and always remember, series can store number. Okay, it can store string, or it can store mixed data. Okay, so different type, this all can be stored in series. Okay, so now if I give just basic example of series, so this is without index. Okay, without index, so we have to write like this: PD, we have to import our pandas first, then we have to write PD dot series. S will be capital. Okay, always remember S would be capital, and within this parenthesis you have to provide a list. As I told you, series is a list. Okay, series is a list, so you can write your list like this. Okay, now if I write print, suppose this is my A. Okay, if I print my A, then it will give me output as I did not mention any index, so automatically index gets assigned. So 0, 10, 1, 20, 2, 30, 3, 40. So these are my value 10, 20, 30, 40. As I did not mention any index, so automatically 0 to 3 index gets assigned to each value. Okay. In the other hand, if we write with index, now for that you have to write like this: B equal to PD dot series, and here you have to provide your list, suppose 10, 20, 30. Now here you have to provide your index. This is basically custom index. Okay, you have to provide index equal to, suppose, A, B, C. Okay, now basically this is your custom index. So I have provided my index over here. Now if I print my B, then I will get my output as A is 10, B is 20, C is 30. Okay, like this. So this is basically, this is without index, where I did not mention any index. So automatically all my value gets assigned with its corresponding index, that is 0 and onwards. And if I am to use any custom index, then I have to write like this, and all the index will be get assigned with its corresponding value automatically. Okay. So, and I will get the output like this. Okay. Now to access the data from my series, what you have to do, as here I did not mention any index, so automatically this is my 0, 1, 2, 3. So if I want to access the 20, this element, then I have to write like this: print, my series name is A, and with this square bracket I have to provide my index. So 20 is having one index, this one. Okay, 20 is having this one index, so I have to provide ones. So I will get answer as 20. Okay. In the same way, if I want to get this 20 over here, then I have to write print B, and within this square bracket I have to provide the index number of this 20. So what is the index of this 20? That is B. So I have to provide B. Okay. Now it will give me the answer as 20. So this is how we can access the element from our series. Okay. Now next is DataFrame. Okay. So DataFrame is two-dimensional data structure. Series was one-dimensional data structure, and DataFrame is two-dimensional data structure. Okay, always remember, series is one-dimensional and DataFrame is two-dimensional. Okay, so DataFrame is just like Excel or table with having rows and columns. Okay, so basically in DataFrame, rows holds the records and column holds the feature. Okay, holds the feature. So basically we can call DataFrame is equal to collection of multiple series. Okay, collection of multiple series. Suppose we have a data like this: name, okay, age, gender. So name is A, B, C, age is 25, 30, 24, gender male, female, male, like this. So I have multiple column over here. Here I have my row. This is called not row, it is basically individual column. Okay, individual column. So these all are feature. Okay, all are feature, and each row is holding my records. Okay, so this is my two-dimensional data which is having row and column. Okay, row and column. Now in order to create your data frame, you have to write pd.dataframe. Okay, pd.dataframe. Just like series, we have to write pd.series. Here we have to write pd.dataframe, and D is capital. Okay, pd.dataframe. And here we have to pass our data. Okay, data means here we don't need to pass only list, because these two dimensions, so we have to pass our row and column both. So we have to basically provide our dictionary. So if you know Python, then you must be knowing about dictionary. So within this curly bracket, we have to provide our row, column, right? Like this. We have to provide our data like this. See guys, if you don't know about Python, I have already created a dedicated video of Python full playlist in my channel. Just go to my channel and check the Python playlist and just watch that video and learn about Python properly. Okay. So as using dictionary, we can provide our data as row and column. So within this data frame, we have to provide our data in dictionary form. So basically we have to write like this. We have to provide our data. First of all, we have to provide our data. Then we have to give our curly brackets. Okay. Now we have to provide our feature. Suppose that it is name. Okay. And within within here, within a list, we have to provide my all values. Okay, A, B, C. My name is ABC. Now again I have to provide one feature, that is age, colon, then in another list I have to call, that is value. Okay, suppose like this. So these are, we can mention as many as column we want. Okay, so now like this we can write marks. Then in this list we have to pass my marks. Okay, 85, 90, 80. Okay, and finally we have to close our curly brackets. So these become our data. Now we have to write, suppose C equal to pd dot DataFrame, and within this parenthesis you have to provide our data, this data. Okay, now if I write print C, then we will get output as name A, B, C, age 20, 21, 22, and marks 85, 90, 80. And each record, each row will get automatically one index value. Okay, so each row will get one corresponding index value automatically. It will get assigned 0, and it will start from 0, 0, 1, 2. Okay, so these are, we can create our data frame, and this data frame is two-dimensional data structure. Okay, now in order to access any record from data frame, we have to write like this: print our data frame name, that is C, and suppose we want to access our age. Okay, then we have to provide like this, age, and it will give output as age 20, 21, 22, and all the records again we have is own index. Okay, like this. And if you want to access multiple column at once, then you have to write like this: print your data frame name, that is C, and you have to provide 2 square bracket. Okay, 2 square bracket, and here you have to provide all your column name. Suppose age, marks, name, like this. Okay, let me just a minute. Print data frame name, then we have to provide 2 square bracket, and here I have to provide all my multiple column. Whenever we need to access more than one column, then we have to provide 2 square bracket, and here we have to provide our column name one by one. Okay, suppose age and marks. Okay, then you have to close our square bracket and parenthesis. Now it will give me the answer as age 20, 21, 22, marks 85, 90, 80, and all my row will get assigned with a index value. Okay, 0, 1, 2, 3, and so on. Okay, so this is my data frame, and this is how we can access our data from data frame. Okay, so I'm creating one folder, data structure. Okay, now I'm creating one file, series.ipy nb. Okay, now I'm selecting my kernel. Okay, now in order to create our first data structure, that is series data structure, we have to import our pandas. So you have to write import pandas as pd. Then I'm getting one series, that is A. Now we have to write pd dot series, and within this parenthesis we have to provide our list. Suppose 10, 20, 30. Now if I print A and execute, see, you can execute by clicking this triangle, or you can execute from your keyboard just pressing shift and enter. Okay, shift plus enter. Now see, this is my series. Now here my record is 10, 20, 30. So this is my 10, 20, 30. And as I did not mention any index, so automatically each value gets assigned with its own index. That is by default, that is from 0 and onwards. Okay, 0, 1, 2. Okay, this is my series. Now this is without index. Okay. Now this is with index. Now suppose I am creating another series, that is B, and here I have to write pd dot series, and within this parenthesis we have to provide first our list. Okay, suppose 10, 20, 30, comma. Now I have to provide my custom index. Okay, this is my custom index, that is index equal to, within a square bracket we have to provide all my index name, that is A, B, C. Okay, now if I print B and execute, okay, this should be dot. Now see, my value is 10, 20, 30, but as I mentioned my custom index ABC, so instead of 0, 1, 2, my index gets assigned as ABC. Okay, ABC. So whenever in our series, whenever you have only value, then automatically index value gets assigned. But if you want to give any custom index, then we have to provide our index like this index, and within this square bracket, that means as a list we have to provide our index, and this index get assigned with all its corresponding value. Okay. Now in the same way you can create any kind of series like marks. Okay, pd dot series. Suppose I am providing 85, 90, 88. Okay, and my index is my subject name. Okay, index is my subject name. So I have to write like this: math, English, science. Okay, now if I print my marks and execute, now see, my index gets math, English, science, these all are my index. So instead of 0, 1, 2, I am getting index as math, English, science, and automatically all the value gets assigned to each index. Okay, these are my value, and automatically gets assigned to each index. Okay, so math is 85, English is 90, science is 88, like this. Okay, so this is how we can create our series. Now in order to access our data from series, what we can do? Suppose I want to access this to 20 element or 30 element. Okay, 30 elements. So what is the index position of this 30? That is 2, right? This is 2. So 2 gets assigned this 30. Okay, so we have to write like this: print, then we have to provide our series name, and within this square bracket we have to provide our index, that is 2. Okay, now if I write 2 and execute, now see, I am getting my value as 30. Okay, now if I want to access my 10, then what is the index position of this 10? That is 0. Now if I write print a of 0 and execute, then I am getting of this 10. Okay, in the same way here, where I have mentioned my custom index, then in order to get the value using the index number, what we have to do? We have to write same. We have to write the same as it is using its index number. Now this is my series B. Now in this square bracket I have to provide my index. As I have mentioned already, I have mentioned my custom index. So I have to provide this index instead of 0, 1, 2. Here my index was 0, 1, 2 because I did not mention any custom index. So it was 0, 1, 2. So in order to access, we have to provide 0, 1, 2. But here I provided my custom index. So in order to get my value, I have to provide this index value only. Okay. So if you want to access the 20, then what is the index value of this 20? That is B, right? That is B. So if we write B, and execute, then I'm getting output as 20. Okay. Now if I write A, so what is the value of A? That is 10. Okay. So I'll get value as 10. Now see, this is my value as 10. Okay. In the same way, here, if I want to get the value of English, because this is my index, so I have to access the value using index only. So I have to provide my index. So to get the value of English, we have to write print, and we have to write our series name, that is marks, and within this square bracket we have to provide our index, that is English. Now if I execute, sorry, we have to put it in a inverted comma. Okay. Now if I execute, now see, I'm getting output as 90. Okay, because the value of English is 90. Okay. Now if I provide science, then I will get output as 88 because science is 88. So I'm getting 88. Okay. These are, we can create our series without index, with index, and this using the index number, we can access our index value from our series. Okay. Now next is DataFrame. I'm creating another file, that is DataFrame .ipynb. Now again I have to select my kernel. Okay. Now in order to create our DataFrame, first of all we have to import our Pandas SPD. Now we have to create our DataFrame first. As we have to pass our data as a dictionary, so first of all let me create my dictionary first, because in DataFrame it is two-dimensional and it is always having row and column. So in order to create row and column, we have to give the data as a dictionary form. Okay. So I'm creating my dictionary first. So this is my data. So suppose my first column would be name, and here I have to pass my values, that is A, B, C. So this is my first column. Now again I am giving another column, that is age. Now again I have to pass my values, suppose 25, 35, 30. Now I have to provide, suppose, gender. Okay. Suppose male, female, and male. Okay. Now my data is ready. Now in order to create our data frame, we have to write like this: pd dot data frame, and within this parenthesis we have to provide my data. Okay. And we can give this name as df. Okay, data frame. Now if we print this df, now see, Pandas module has data frame. Okay, sorry, ape also will be capital. Okay, D is capital, ape is also capital. Okay. Now if I execute, now see, this is my data frame. Okay, it is having row, this column, name, age, gender, and these are my column row. This is my column, age, name, gender, and these are my row. Okay. So this is my data frame. So see, here I did not mention any index. So automatically each value gets its own index, that is 0, 1, 2. Okay. And this is having two-dimensional because it is having row and column, and it is just like a table. Okay, just like a table. So this is why it is called data frame. Okay. Now we can create another data frame like this. Suppose sales. Okay. Now I'm creating my dictionary first. Suppose this is my product, and I need to pass my list of product. Suppose laptop and mobile. Okay. Now next column is price. Suppose $50,000 and $10,000. And the other column is quantity. 5 and 10. Okay. Now my data is ready. Now I have to create my data frame using this data, right? So for that we have to write, suppose df2 pd dot data frame, and within this parenthesis I have to pass my data with sales. Now if I print df2 and execute, now see, this is my data frame. Okay, it is having my column, product, price and quantity, and here this is my row, laptop 50,005, mobile 10,000 and 10. Okay, and each row is having its own index number. Okay, starting from 0. Okay, so these are we can create our data frame. Now in order to access the data from data frame, what we can do, we can write like this: print df, and within a square bracket, if you want to access a single column, then you have to just pass a single square bracket, and here we have to pass our column name. Suppose age. Okay, now if I execute, now see, you are getting a single column, and each column, each row is having its own index number. Okay, now if you want to access age and gender both altogether, then you have to provide two square bracket, age comma gender. Okay, now if I execute, now see, we are getting age and gender both altogether. Okay, in the same way, if you want to access here, suppose print df2, and you want to access product and quantity. Okay, these two column, then you have to provide two square bracket, and within here we have to provide our column, that is product, and another is quantity. Okay, now if I execute, now see, I'm getting product and quantity. Product is laptop 5, mobile 10, and each row is having its own index number. Okay, so these are we can create our data frame using any number of columns, and these are we can access our data from data frame. Okay, whether it is single column or it is multiple column. If we need to use single column, then we have to provide a single square bracket, and you have to go, and if you want to access multiple column, then you have to provide two square bracket and provide all our column name one by one. Okay, now our next topic is data inspection. Okay, data inspection and exploration. Okay, so basically data inspection means EDA. EDA. The full form of EDA is exploratory data analysis. Okay, so basically before analyzing your data, we need to first understand your data, right? So this step is called EDA. Okay, so whenever you get any kind of data from anywhere, it might be Excel or CSV or SQL or JSON or API, whatever it is, whenever you get your data first, then you have to look for how data looks like. Okay, then you have to find out you need to find missing values. Okay, because most of the time your data, whenever you get your data, most of the time your data will have messy data. Okay, so you have to clean your data first. So for that, you have to, first of all, you have to look your data, then you have to find the missing values, then you have to understand the pattern of data. Okay, then you have to delete all the error. Okay, you have to delete all the error or rectify the error. Okay, or rectify the error. Either you have to delete your error or you have to rectify. Okay, so these are the few steps that you need to perform whenever you get your data, and this is called EDA. Okay, this is called EDA. So basically, the first step of any data analysis is called EDA. And to perform this EDA, so basically Pandas provides many function. Okay, many function to explore your data easily. That is called basically to perform your EDA. Okay, so there are few inbuilt function that Pandas has. Okay, so let's see one by one. So first one is dot head. Okay, dot head. This basically give help us to view first 5 row in our data set. Okay, suppose you have a data where you have columns. Okay, column 1, column 2, column 3, column 4, like this, right? And you have your data over here. Suppose A, B, C, 1, 2, 3, 5, 6, 7, 8, 9, 10, like this. Okay, so these are the column that you have, and these are the records. Okay, these are the records. So whenever you perform dot head of function, then automatically you get all the columns name, that means all the features. Okay, and the first five rows. Okay, so using dot head method, you will get all the features, that means all the column name and first 5 records. That means first 5 rows. Okay, you get top 5 rows. Okay, so to quickly look at your data, we need to use this head function. Okay, we need to use this head function. Usually it shows the first 5 records, top 5 rows, so top 5 records, so you can understand the structure of your dataset properly. Okay, now dot head, and if you don't pass anything in this parenthesis, then it will give top 5 records, right? Now, for example, if you want to have 10 records, then just you have to provide 10 over here, and it will give you the 10 top records. Okay, now if you provide 15, you can provide 20 like this, so it will give 15 records, it will give 20 records, that means top 20 rows. Okay, so like this, whenever you need to look at your data, just pass your dot head function, and if you want to get only 5 records, then don't pass anything, and if you need any more than 5 number of records, then you just need to pass your number. Okay, and you will get the top rows accordingly. In the same way, if you want to see the last rows, okay, using head, we can see the top rows, and if you want to see that bottom rows, that means the last record, then you have to use dot tail function. TAIL. Okay, dot tail function. And if you don't pass anything in this parenthesis, then it will give bottom 5 records. If you want to see any number of records, then you have to pass like this. Okay, 10 bottom records. Okay, 5 bottom records, bottom or last record, that means rows. Okay, so in order to get top records, we have to use dot head, and in order to get our last record, you have to use dot tail function. Okay, and both function works in the same way. Next is dot shape method. Okay, dot shape method. So dot shape method basically we use to know how big your data set. Okay, so it basically gives you row and columns, how many row you have and columns. So basically, if this is my data, if this is my data set, then here I have how many columns? 1, 2, 3, 4. So if I pass dot shape, and this if this is my data frame, okay, then if I pass df dot shape, then it will give me the output as how many rows I have? 1, 2, 3. So 3 rows, 4 columns. Okay. So to find out how many columns and how many rows we have in my data set, we use dot shape method. Okay. Next is dot info. Okay, dot info. Basically, this info function gives you complete summary of your data set. Okay. So if you write like something like this df dot info, okay, this df your data set, then it will give different type of information, just like column name, okay, data types of your data set, okay, how many non null value you have, in your data set, okay, how much memory it is using, so each and every details will be shown by using this dot info function. Okay, next we have dot describe. Okay, so to understand numerical data we use describe. Okay, so basically this it gives the statistical summary of our data. Okay, so basically using dot describe we can get mean of our data, okay, minimum, maximum of our data, what is the standard deviation, okay, what is the percentile, of our data. So all this information we get using dot describe function. Okay, using this dot describe function we can get all this information at once. Okay, next we have dot column. Okay, dot columns. So basically these shows all the column names. Okay, so if you want to see all the column names in your dataset, then just use dot columns and it will give all the column names. Okay, and another is dot index. So it basically shows row labels. Okay, row labels. So if you have to see any kind of row labels, means index, okay, any index of any row, then you can use dot index. So it will give you the index position of that row. Okay, next we have dot value underscore count. Dot value underscore counts. Okay, so it basically gives how many times each value appears. Okay, that means suppose we have column 1, column 2 like this. Okay, so suppose in this column here I have A, B, C, A. Okay, this is my record. Now if we write, this is my df, this is my data frame. Okay, so suppose I write df dot value counts. Sorry, I have to pass the column name. df now if I pass column 1 dot value underscore counts. Okay, then it will give me answer as A is 3, because I have A 3 times, right, in my data. So A is 3, B is 1 because B is 1 times in my data, and C is 1 time of in my data. So and C is 1. Okay, so basically it counts how many times each value appears in my data. Okay, So it basically shows frequency of data. Okay, frequency of data. And always remember, it is useful in case of categorical data. Okay, categorical data. Right? It is not useful in numerical data. Numerical data. It is not useful in numerical data. Okay, it is only used in categorical data. So if you don't know about categorical data or numerical data, let me tell you. Okay, so basically categorical data is basically represent labels or category. Okay, just like if you in your data set, when suppose you have gender column, okay, gender column, that is male, female. Suppose city column, okay, New York, Los Angeles or Chicago, anything. Okay, you might have product type, suppose laptop, mobile. Okay, so these are categorical data. Okay, these are categorical data. And in the other hand, numerical data, basically numerical data represent numbers. Okay, represent numbers that have measurable meaning. Okay, that have measurable meaning. Okay, that means suppose in your data you have column like age. Okay, 20, 30, 40, something like this. You may have salary, $20,000, $50,000, or $80,000, something like this. So these are category numerical data, because you can measure all this data. You can measure all this data. That means basically you can perform mathematical operation. Okay, you can do any kind of mathematical operation on this data. So whenever in your column you have numerical data and you can perform different type of mathematical operation like addition, average, multiplication, anything, then those column are called numerical data. Okay, numerical data. So our value counts work in categorical data only. Okay, on categorical data only. So I'm creating new folder, data inspection and exploration. Okay, now I'm creating one file, eda.ipynb. Okay, now let me select my kernel. Okay, now I have to create my data frame first. Okay, so for that I have to import my pandas. Import pandas as pd. Okay, now I have to define my data frame. Okay, pd dot data frame, right? And here I have to pass my data. So I have to create my data as dictionary. So let me create my data first. First column I am to give, that is name. Okay, and this is my list of name. Suppose A, B, C, D, E, F, G. How many name I have given? 1, 2, 3, 4, 5, 6, 7. Okay, it's 8. Okay, 8. And another column I am to give, that is marks. And here this is my list of marks. About 85, 75, 80, 60, 63, 73, 81, 1, 2, 3, 4, 5, 6, 7, and another is 80. So 90. Okay, so this is my data. Now I have to provide, in order to create my data frame, I have to provide my data, right? Now if I print my data frame, sorry, I have to print it without overriding. Now see, this is my data frame. Okay, this is my data frame. That means this is my data set. Okay. Now first we will see about dot head. Okay. So let me write my markdown dot head function. Dot head function. So what we have to do? We have to write print and we have to pass my data frame, that is df dot head. df dot head and put a parenthesis over here. Now if I execute this cell, now see, it is giving me top 5 record. Okay. A, B, C, D, E. This is my top 5 record. So it is giving me top 5 record. Okay. So using dot head, I can get my top 5 record. So using this, I can get all my columns names. I can get top 5 records to see what is my data about. Okay. Now if I want to see below 5 records or above 5 records, then you have to pass my digit over here. Suppose if I want to see top 2 records, then I have to pass 2. And if I execute, now see, I'm getting 2 records on this. Okay, top 2. Like this, if I pass top 6, then I'll get top 6 record. Top 6 record. Okay. So as I have only 8 records, so I cannot give the example of more than 8. Okay. So if I provide 8, so it will give the 8 records. So accordingly, how many records you want, you just put the number over here. If you don't pass any number over here, then it will give by default top 5 records. Okay, top 5 records. And if you want below 5 or above 5, then you could pass that digit over here. Okay. So this is my head function. This is how head function works. Next is tail function. Okay. Tail function. So the tail function works as just same as dot head, but it gives the output from bottom. Okay, from bottom. It gives the record from, it will pick up the record from bottom side. Okay, it will pick up the record from last. Okay, so if you write print df dot tail and just put a parenthesis, that means I did not pass any digit over here. So it will give me the output from last. Okay, from last 5 record. Okay, this is my markdown cell, so I have to convert it. Okay, now if I execute, now see, I'm getting last 5 records. Okay, 7, 8, 6, 5, 4, 3, 1, 2, 3, 4, 5, 5 records. So this is my last 5 records. From bottom, if you count, then this is my last 5 records. Okay, now if I want to see last 3 records, then I have to pass this digit. Now see, this is my last 3 record. Okay, in the same way, if you want to see last 7 records, now see, this is my last 7 record. 1, 2, 3, 4, 5, 6, 7. Okay, so dot tail works same as dot head. Just the difference is using dot head we get top records, and using tail we get our bottom records. That means last record. Okay, and in both cases, if you don't pass anything in this parenthesis, then it will give by default 5 records. And if you want below 5 or above 5, then you have to put that digit number on it. Okay, accordingly you will put your answer. Right. Next is shape. Okay, dot shape method. For that, I have to write print my data frame name dot shell. Okay. Now if I execute, now see, this is my row, this is my column. So I have 8 rows and 2 columns. Right? I have 8 rows. And I have 2 columns, name and marks. Okay. So to find out the row and columns, how many columns and row I have in my data set, we normally use dot shape method. Okay. Fine. Now next is dot info method. Okay, info function. Now if I write print df dot info and execute, now see, it will give the entire information about my data set. So see, this is my column. That means these are my column. Okay, name, marks I have. How many non-null data I have? So I have any null number? No, all are filled. Okay, there is no null number. So it is showing 8 non-null. Marks is also having 8 non-null value. Okay, so if I have any kind of null value over here, then it will show here as well. Okay, how many null value is there, how many non-null value is there, everything it will show. Okay, and the data type. Now name is my string data type, right? Name is my string data type and marks is my integer data type. So it is showing data type is name is string and marks data type of marks is integer string code. Okay, so basically using .info we can get complete information about our data set. Okay, now next is .describe. Okay, so to get the statistical summary of our data set, we normally use describe. Okay, so for that we have to write print df dot describe, and if I execute, now see, it is giving a statistical, because statistical calculation is applicable only on numerical data, right? Only numerical data. So it is giving me output on marks data only, because marks is my numerical data, right? Name is my string and marks is my integer. So it is giving me output on marks data only, marks column only, not name. Okay, because all the statistical mathematical operation happens on numerical data only. Okay, so see, on marks, what is the count of my this column? How many column I have? That is count. Okay, so 8 value is there in my marks column. 8 column row is there, so it is showing count as 8. So what is the mean of this column? That means what is the average of all this number? Average of this column marks, that is mean. Okay, that is 75.87. What is the standard deviation? That is 10.37. The minimum number, that is 16. If you find the minimum value of this row of this column is 16, right? And maximum value is 19, right? So see, this is my minimum value, that is 60. This is my maximum value, that is 90. Okay, this is my 25 percentile. So 25 percentile of my data is 70.5. 50 percentile of my data is 77.5, and 75 percentile of my data is 82. Okay, so these are the statistical information of my data set on all numerical data. Okay, only on numerical data. So if you have multiple numerical data, so you get the same thing one by one. Okay, now these marks, suppose you have age, suppose you have sales data. Okay, so if every numerical data you have in your data set, .describe will give complete statistical calculation of all that columns. Okay, next is .column and .index. Okay, so .column we use .column in order to get all our column names, and .index you use .index in order to get the all row labels. Okay, row labels, right? So if I write print df dot columns, and if I write df dot index and execute, now see, df dot columns, these are my columns, that is name and marks. These are my columns, so it is giving me the output as name and marks. Okay, so these are my column, and index is, see, range index start from 0, stop 8, step 1. So guys, if you know about Python, so then you might be knowing how range function works in list in Python, right? So this is the same thing. This is my start value, this is my end value, and this is my step. That means our start value is 0 and stop value is 8, but always remember this stop value gets excluded. Okay, and step 1 means it will increase by 1. That means our start is 0. So if you go over here, this is my index, This is my index, right? This is my index. So index start from 0 and step is 1. That means it will increase by only 1. So 0, 1, 2, 3, 4, 5, 6, 7. And stop is 8. That means stop is excluded. So it stop basically a stop minus 1. That means 7. So it will start from 0 and end with 7. And step is 1. Okay. This is my index. So this is how range function works in list in Python. So in the same way, it is showing like this. Okay. This is my index. So index is my 0 to 7. So starting from 0, ending with 7 because 8 is there. So 8 minus 1, 7 and step is 1. Okay. So these are we can get our column names and index. Okay. That means row levels, right? Next is value counts. Value counts. Okay. So let me do one thing. Let me copy the same things. I'm adding DS2. Okay. Now here I'm creating A, B, again A. This is C and this is D. Okay. I'm writing like this. Now see, this is my data frame. Okay. Now if I write print df2 of mark name dot value counts dot value counts. I told you value counts always works on categorical data only. Okay, categorical data. So that means it will give me the count of how many elements I have. How many elements I have. So how many A I have, how many B I have, how many C I have, everything it will give. Okay. Or this would be 2. Okay. So this is my data frame. Now when I perform my value counts on my name column only, then it will give how many A, B, C, D, how many A, B, C, D I have. Okay. So now if I execute, now see how many A I have, that is 2. See, this is 1A, this is 2A. So I have 2A only. Okay. So 2. How many D I have? Now see 1D, 2D. D is I have 2D. 2D. Okay. 2D. And B is 1, C is 1, F is 1, H is 1. Rest are all are 1. Okay. Only A and D is appearing 2 times. Okay. So basically it counts all the data, how many times this data gets appear. Okay. So I have 2 times, I have 2 times A, 2 times D. Okay. This is how it gets printed. Right. Guys, right now I'm giving the complete overview of Pandas, how Pandas work, how all the inbuilt function works in Python with our data set. Okay, so if you have any type of confusion about this function, how they actually works, so don't worry. In once my complete overview will be completed, then I will take a complete new data set. Okay, complete data set where you have multiple columns, multiple rows, and on that time I will apply all this function on that data set only. Okay, then you get complete picture on all this function, how they works on actual data set. Okay, so don't worry, I will give a complete example with complete data set, right? In this module, we'll see how to basically reading and writing our data. Okay, writing of data. Till now, we have seen how to create our data frame, right? Data frame. Basically, we have used our manual process, that is pd dot data frame, right? So using this pd dot data frame, we have created our manual data set. Okay, manual data set. But actually, whenever you work in real project, then always your data will be stored in either CSV file or Excel file or JSON file, okay, or SQL, whatever it is. Okay, so whenever you get your data, the process is first you have to read your data. Okay, you have to read your data. Second, you have to convert this data to data frame. Okay, convert to data frame. Third, you have to clean your data, because if you have messy data, then you have to clean your data. Okay, and fourth, you have to save back the same. You have to save back the clean data to that file. Okay, so basically, first of all, you have to read your data, then you have to convert it in data frame, then you have to clean your data, then you have to save back that clean data in the same file. Okay, this is the entire process. This is the entire process of reading and writing your data. Okay, so whenever you do any kind of data analysis process, this is the process, these are the steps you have to perform. Okay, so without this you cannot work on your data. Okay, so pandas provide different type of inbuilt function by which we can read our different type of data. Okay, for example, if you have CSV data, then pandas provide one inbuilt function, that is pd dot read underscore CSV. Okay, if you have Excel data, then you have to write pd dot read underscore Excel. Okay, if you have JSON data, then you have to write pd dot read underscore JSON. Okay, like this. If you have SQL data, then you have to write pd dot read SQL. Okay, so these are there are different type of function is there. Using this, you can read your different type of files. Okay, now you have already read your data. So once you read your data using this function, so automatically it gets converted to our data frame. Okay, so basically you read your data, then you convert your data to data frame. Okay, now you have to clean your data. Then once your data is clean, then you have to again save back this clean data to that file. Okay, so in order to save the file to CSV, you have to write, suppose this is your data frame, this is your data, you have cleaned all your data, right? Now you have to write df dot to underscore CSV. Okay, in the same way, if you want to save in Excel file, then you have to write df dot to underscore Excel. If you want to save it in JSON, then you have to write df dot to JSON. Okay, so these are you can save back your all data in different type of function, different type of files. Okay, so I hope you understand how using pandas different type of input function, how we can read our different type of files. Then we have to convert it in data frame. Then we have to clean our data. Then once our data is clean, then we have to save back that clean data in different type of files. Okay. Now I'm creating new folder, data reading and writing. Now I'm creating one file, data.pyn. Now I'm selecting my kernel. Okay. Now here I'm creating another file, that is suppose a.json. Okay, I'm creating one JSON file. As I will give you the example of reading JSON file, CSV file, Excel file. Okay, so for that I have to create, first of all I have to create one JSON file. Now I'm writing name A B C H 20, 30 and 40. Okay, so this is my JSON file. Okay, and I have kept two original datasets. One is Titanic.csv and another is Titanic2.xls file. Okay, so this is my CSV file and this is my Excel file. Okay, so for reading my file, I have to import my pandas first. Import pandas as PD. Okay, now I have to read my files. So I'm giving one name that is df. Okay, and I have to write pt dot read underscore csv. Now I'm reading my CSV file. Okay, so I have to copy my relative path and I have to provide my relative path. Okay, here this folder name is not required. Now if I execute my df, now see, this is my entire data. Okay, this is my entire data. It is having passenger ID, how many survived, passenger class, name, sex, age. Okay, every data I have. So whatever data I have in my CSV file, everything is visible over here. So I can read my CSV data. Okay, I can read my CSV data. Now in the same way, if I want to read my Excel file, then I have to write it same like this. Just here I have to change read underscore Excel. I have to write read underscore Excel. Okay, and here I have to pass my original file name, that is Titanic2.xlsx. Okay, now if I let me give another name, that is df1. Okay, df1. Now if I execute now see the same file I'm getting. Okay, my Titanic2 file. Okay, this is my Titanic2 file. So I'm reading my XLS file. Okay, now if I need to access my JSON file, then I have to write same thing. Just I have to write over here read underscore JSON, and here I have to pass my file name, this a.json. Okay, now if I execute, now see, I'm getting my JSON file. Okay, so this is how you can read any kind of file. Now if you write just pd dot read, and you get all the option that you can use. Okay, so this is your CSV, this is Excel. Okay, there are different type of file that you can read. This is my JSON, this is my pickle file, SAS file, SQL file, SQL query, SQL table. Okay, XML file. So you can use different type of files over here, and you can read in the same way. Okay, so you can read over here. So this is how we can read our different type of data. Okay, now suppose you have read your data and you have clean your data. Now you have to save it back to the data, clean data in the same file. Okay, now for example, write data. Okay, let me write read data. Read data. Okay, this is my read data. Now write data. Okay, so okay, let me change the file name. This is df2. Okay, this is df2. This is my df2. Okay, so this is my df1. This is my df2. Sorry, that is df. Okay, that is df. That is df1, and this is my df2. Okay, fine. Now I want to save my clean file in CSV extension. Okay, now for that I have to write df dot to underscore CSV. Now see, you get all the option. You can save in CSV, dictionary, Excel, okay, HTML, JSON. So whatever you record, you can save your file accordingly. Okay, now I want to save it in CSV file. Okay, now to CSV. Now here I have to pass my file name. Okay, now I am to give a new name, that is uh, clean Titanic dot csv. Okay, and here I have to pass index equal to false. Index equal to false means I don't, as this is my data frame, so automatically each data frame gets its own index value. This is it, this 0 1 2 3, right? So automatically my all my data gets its own index value. So when I want to save this data back to my csv file, then I don't want this index value to be saved. Okay, I don't want this index value to be saved because this is unnecessary. Okay, so that is why I need to write index equal to false. If you write index equal to true, then this column, this index number also gets saved in your file. Okay, so these are necessary, so I'm not saving all these things. So I'm just write index equal to false. Okay, now if I execute, now see, in the same path one file gets created, that is clean.csv. Now see, okay, in the same path clean_titanic.csv file gets created. Okay, so this is my clean version. Okay, this is my clean version. In the same way, I want to save my df1 file, that is excel file. Okay, excel1, I want to save that file to excel. Okay, to excel. Here I want to give name as clean Titanic 2 dot excel6. Okay, and here also I want to pass my index as false. Okay, now if I execute, now see, again clean.titanic 2 excel file got created. Okay, this file also get created, right? In the same way, if I want to save my JSON file, that means df2 file. Okay, now see, again I have to write like this, df2, my JSON file is df2, right? JSON file is df2, so I have to write df2 dot to JSON. Okay, to JSON, and here I have to pass my file name. Okay, suppose clean underscore a, okay, dot JSON. Now if I don't pass over anything here, then automatically the index gets stored. Okay, now if I don't want to store my index, then we have to pass orient. Okay, orient, and here I have to pass records, not index equal to false, because JSON doesn't treat index in the same way CSV does. Okay, CSV or Excel does. So it treats in different way. So in order to not saving the index in JSON file, we have to write orient and equal to records, not index equal to false. Okay, now if I execute, now see, I got a file that is clean underscore a, and now see, clean underscore a, this is my JSON file. Okay, now see here, there is no index number. Okay, there is no index number. So I hope you understand how to read our different type of data using Pandas inbuilt function. Okay, and after working on the data, how to save back that clean data in different type of files. Okay, now we will see how to perform data cleaning. Okay, how to perform data cleaning in dataset. So basically, before analyzing our data, we need to clean our data. Okay, whenever you will get your data in real world scenario, then most of the time your data is messy. Okay, most of the time your data will be messy. So messy means it will have missing values. Okay, it will have duplicate rows. Okay, your data might have wrong data type. Okay, wrong data type. Your column name might be written in wrong. Okay, wrong column name. So for that you have to rename your column, right? So these are the messy data. Okay, these are the messy data. So before analyzing, you have to load your data. And then you have to clean your data in order to perform the data analysis. Okay, in order to perform data analysis. Okay, so in this module, basically what we'll going to do, we'll load our real data. Okay, real data. Then we convert it in DataFrame. Okay, then we will find out how many missing values or nan values. Okay, nan values is there. Then we will try to delete all these records or modify these records based on our requirement. Then we will try to find out how many duplicates record we have. Then also we will delete all these things or modify. Okay, or modify our these records. Then we will perform renaming of columns. Okay, how to perform all these things we will see. How to change data types. Okay, so before analyzing we have to perform all this operation. Okay, so in this module we will see how different type of inbuilt function of Pandas works on real data set to clean our data before performing any kind of data analysis. Okay, now I'm creating one new folder. Okay, that is data cleaning. Okay, now here I'm creating one file, data clean .ifyn. Okay, now let me select my kernel. Okay, now first of all I have to import my pandas. Okay, so import pandas svpd. Now I have to load my data. Okay, for that I have to keep my one data set in the same folder, right? So I have kept the same Titanic file in this same folder. Okay, now I have to read my data first, right? So in order to do that, I have to write df. Now basically reading the data, that means we converting our data into DataFrame. Okay, so df dot pd dot read csv, because this is my csv file, so I have to write ed dot read csv, right? And here I have to pass my file name, that is Titanic dot csv. Okay, now if I try to see my data frame, now see, this is my entered data. Okay, this is my entered data. That means I have read my data and converted it in data frame. Okay, so now if I want to understand properly, then I have to write df dot head. Okay, df dot head. Now if I execute, now see, it is giving me top 5 records. Okay, so it will help me to understand how my record look like. Okay, so these are my column name. Okay, these all are my column name, and these are the records. Okay, if you can say these nan means these are the missing values. Okay, these are the missing values. So basically Kevin, this column has multiple missing values, so we have to fix all these things. Okay, so next is, if we want to see the complete information about our data set, then we have to write df dot info, right? Okay, before that, if we want to see how many row and columns is having in this data set, so we can write df dot shape, right? So now if I print, now see, it is having 891 rows and 12 columns. Okay, so this data set is having 12 columns and 891 rows. Okay, so now in order to see the entire information, we have to write df dot info. Now see, the entire information is getting over here. So this is my index, so this is my column name. Okay, passenger id, survive, passenger class, name, sex, everything. So how many records this particular column is having? It is showing 891 null. That means we have 891 records, right? So 891 non-null means this passenger ID is having all the ID. It doesn't have any kind of missing values. Okay, in the same way, survive is also having complete data. It is not having any missing value. P class is having, now see, in age, now see, age is having 714 data. That means remaining data is missing. Okay, in the same way, if you see Kevin Kevin is only having 204 data. That means all are remaining is missing. Okay, so we have to fix all these things. Now data type. So it is giving me information about the data type of the these particular columns. Okay, this integer, this integer, this integer. So name is string. Okay, name field is string. Now age is float. Okay, age is float. Now this is one of the issue, because age cannot be float, right? Age is always integer. So we have to change this data type. Okay, so this type of messy data we have in your data set, then and we have to clean all these things one by one. Okay, so basically before processing any kind of cleaning process, you have to understand your data properly first. Okay, so how many columns you have, how many missing value you have, so you have to find out all these things, then you have to perform your cleaning process. Okay, so this is how we can get how many these are my missing values. We have different wrong data types. Okay, so you have to understand that. Now we can perform df.describe to understand all the statistical calculation on our data. Okay, now see, those columns data type is having float or integer, only on that column we can perform different type of mathematical operation. So these are the column that is having only numerical data. Okay, so describe doesn't perform on string data. Okay, string data, it cannot perform string data because describe means statistical mathematical calculation, so it will always applicable on numerical data. So all the field that is having numerical data, that is showing over here. Okay, so basically these are my column. Okay, column name, and each column is how many counts is there, what is the mean of this column, what is the standard deviation, what is the minimum value, what is the 25 percentile, what is the 50 percentile, and what is the 25 percentile, and what is the maximum value of this particular column. Okay, so each column is having its different value. So this is how you can understand everything. Okay, so primarily you understand what is your data about, and is there data is in your data, do you have any missing values or wrong data types, all these things you can understand is primarily. Okay, now you have to check it properly. Okay, so you understand that there is a missing value. Okay, now you have to understand how many missing value is there. Okay, how many missing value is there. So if you perform df dot is null, okay, df dot is null, and execute. Now see, false means these all are having data, this is not any missing values, and true, this is true. True means these are missing values. Okay, these are missing values. So df dot is null is normally give all the field as true or false. Those are true, that is missing value. Those are false, that is not missing value. But this is not understandable, right? So in order to get exact number, we have to write df dot is null dot sum. Okay, dot sum. Now if I execute, now see, it is giving me exact number. Passenger ID is doesn't have any missing value. Survivor is doesn't have any missing value. Okay, now see, age is having 177 missing values. Okay, and again Kevin is having 687 missing values. Embark is having 2 missing values. Okay, so using df.isNull.sum, automatically your data will summarize and give how many missing values there in each column. Okay, now you understand your data is having missing data, right? Now you have to handle this missing data. Now there are two ways to handle this missing data. One is you can drop your entire missing data either, or you can fill your missing data with some values. Okay, so see, if your missing data is very nominal, then you can drop all these records. Okay, but if your missing record is maximum, that is covering most of the data, that means if in this data set you have 891 data, but in Kevin you have 687 missing data. Now if you drop the entire 687, then your data will have very minimum records, right? And on that case you cannot perform any kind of data analysis on your data, because your data is less records, and your data will not give any perfect accuracy. Okay, on this type of case you have to fill all these missing records with some logics. Okay, so I'll show both process. Okay, first one is drop. Okay, drop missing records. Okay, Now in order to drop your records, you have to write df dot drop na. Okay, drop na, because drop na, that means you want to drop your all na value, okay, not available value. Now you want to keep all the record in a new data frame. Okay, now drop na. Now if you write new df dot shape, that means after dropping all my missing values, this is my new data frame. Now after dropping, if I want to see the shape, now see, now if I execute, now see, only 183 records is there. Okay, because all remaining are, all missing fields are get deleted, so only I am having 183 records. Okay, so this is the thing you have to think before processing. Okay, because see, in your data is only having 891 records. Among them, after cleaning your missing data, you have only 183 records. This is very nominal, right? So in the here, if you want to perform any kind of data analysis process, then it will not give any perfect accuracy. So this type of case, you have to fill your missing data with some values. If your data is having very minimum number of missing value, then you can drop. Okay, you can drop. But as this data is having huge number of missing fields, so if you drop all these fields, then we have very minimal record. Okay, so we cannot perform data analysis process. So in this case, we have to perform data filling. Okay, data filling. So basically we need to perform filling data. Okay, that is called fill na data, filling na data. Okay, so for that you have to write, suppose we have age 177 field is missing. So suppose I want to fill all these missing fields as 0. Okay, all the missing fields that is having this age column, I want to fill all this field as 0. Okay, so for that, what I can do, we can write df, and here I have to pass my field name, that is age. Okay, equal to df, and here I have to pass my same column name. Okay, dot fill na, and we have to pass my 0. That means I am performing my fill na operation by 0. I am filling all my missing value with 0. So this is my fill na operation. Now I am performing this fill na operation on my df age column. Okay, that means this age column. Okay, and to access this age column, we have to write like this, df, and within this square bracket, we have to pass my column name. Okay, so I want to perform this fill na operation on age column, right? And I want to replace all my data, and I want to save this on the same column. Okay, so once fill na operation will perform on my age column, then all the data will again save back to the same column. Okay, now if I write df dot is null, okay, df dot is null dot sum, and if I execute now see, age is having only 0 record, missing records. Okay, because I have filled all the missing records in age with 0. Okay, that is why now I am getting 0 age column is having 0 missing values. Okay, so I have performing my fill na operation on age. In the same way, I can perform this fill na operation on cabin as well. Okay, now in the same way, I need to fill all the missing value of embark column as well. Okay, now I'll show you how you can fill all these records all together. Okay, now for that, let me execute my data once. Okay, because my data age already is filled by 0, so I need to revoke that. Okay, so this is my data. I refresh my data. Now if I execute this one. Okay. Now execute. Now see. Okay. Now my age is having 177 records, missing records. Okay. Now I will perform fill in operation to all the columns all together. Okay. Now see, I want to perform age. I want to fill all the missing value of age. Instead of 0, I want to fill the value as mean value. Okay. I want to fill all this missing value is of mean value. That means my age is having mean value of 29. So basically it will replace all the missing value with this mean value. Okay. And Kevin and embarked is my string value. Yes, Kevin and embarked is my string value. So I cannot perform any kind of mathematical operation on it. So I can replace all the missing value with unknown. Okay, with unknown. Now let's perform it. Now I have to write. Let me mark down one thing. Fill all column missing value together. Okay. Now for that I have to write df dot fill na, right? df dot fill na, because using this fill na function we can fill our fields. Okay. Now as I have to perform my fill in operation on multiple columns, then I have to pass all the columns as a dictionary form. Okay, as a dictionary form. So my first field is age. Okay, my first field is age. Now I want to fill all my age of its mean value. Okay, so for that I have to write df. I want to perform on age column, right? So I have to write df age dot mean. Okay, that means the mean of this column, okay. So df age dot mean means the mean value of age column. Okay, so it will fill all the missing fields of age column. Okay, now second one is we have Kevin, right? We have Kevin. And I want to replace all the missing value as unknown because these string value. Okay, this string value. So we need to write some unknown or something like this. Okay, we cannot perform any kind of mathematical calculation on it. And the third one we have embarked. Okay, embarked. And this one is also string. So I have to fill all the missing field as unknown. Okay. Now see how many. Now see, age is having 177 missing value, Kevin is having 687, and embark is 2. Okay. Now I'm filling all these missing values. Okay. Now I'm executing this field. Okay. Unknown. Now see, Kevin, all the missing value gets replaced by unknown. Okay. All the missing value of Kevin is replaced by unknown. In the same way, embarked is also having all the missing value replaced as unknown. Okay. And all the missing value of age. Okay. All the missing value of age get replaced by its mean. Okay. Now if you want to see the missing values, now if I write df dot is null dot sum, will execute. Now see, my data set is still having this missing data. Okay, why? Because we have performed our fill any operation and all my data gets updated on my data set. That is okay, but it is not actually replaced my original data. It is not replaced my original data set. So in order to replace my entire original data set, I have to write in place equal to true. Okay. Now if I execute and then try to find out the df.isNull.sum, then it will show 0. Okay. That means with in place without in place equal to true, your required data is updated on the missing fields. Okay, but that is not replaced. That is not replaced in your dataset directly. So in order to replace your all the required data in your missing data and replace in your dataset directly, you have to write impress equal to true. Okay. Now once you write impress equal to true, your entire original dataset get replaced. Okay. Now your all the data is having 0 missing fields. So we have cleaned our data. Now we have to find how many duplicates records we have. Okay. So for that we have to write df dot duplicates duplicated dot sum. Okay. Now if I execute, it is showing something like this, because that means we don't have any duplicates value in our record. Okay. Now I just show you, if we have duplicate value, okay, then there are two options. That is, one is df drop duplicates. Okay. Now if you perform df drop duplicates, then automatically all the duplicate value in your data set will remove automatically. Okay. And another way is, if you want to suppose you have duplicate value on name field. Okay. You have duplicate value in name field. Now you want to perform duplicate operation, drop duplicate operation on name field only. Okay. In order to do that, just you have to write df drop duplicates, and here you have to pass your column name, that is subset equal to name. Okay. That's it. So if you want to perform drop duplicate in entire dataset, then just write df drop duplicate. And if you want to perform it your drop duplicate operation on any particular column, then you have to pass this subset equal to that field name. Okay, that column name, and it will remove all the duplicate value from this particular column. Okay. So these are, we can delete our all duplicate value. Okay. Now next is, now suppose when we have like our column name is like this. Suppose for our analysis, this p class, that means passenger class, this p class short name is somehow it is not recommended for me. Okay, it is not acceptable for me. So I want to rename this column name, so that it will help me to understand properly. Okay. So for that, for renaming, okay, renaming column. Okay, renaming column. So to rename our column, we have to write df dot rename. Okay, df dot rename, and we have to write columns. We have to write columns. Columns, and here within a curly brackets, you have to pass my I have to pass my column name, which is already having in my dataset, that is p class. Okay, that means this one, p class. Okay. Now I have to put a semicolon, and here I have to pass my new field name that I am to keep. Okay. Suppose instead of p class, I am to write passenger class. Okay. So this is my new name that I want to give. Okay. And here I have to pass in place in place equal to true. That means I want to update my field name in my original data set. Okay. Now if I write df dot head and execute, now see my p class, initially it was p class, so it gets replaced as passenger class. Okay. So basically I replaced my original column name with my new column name. Okay. So I just rename my column name. So this is how you can change any column name. Okay. You can rename any column name. Okay. Based on your requirements. Right. Now next is change data type. Okay. change data type. Now see, you have previously seen our age field is having float value, but age field should have integer value, right? So in this column my data type is wrong, so I have to change this data type. Okay, so how to do that? Just we have to write df, and we want to perform the operation on age field, right? Age, df of age dot as type. Okay, dot as type, and within this as type I have to pass in which data type I want to convert it. Okay, so I want to convert it in integer. I have to write int. Okay, and I want to keep this updated value in the same column, that is df dot age. Okay, that means I am to perform my data change operation on each field, and then again I want to replace all the value with the same field. Okay, now if I try to find out the info, okay, now see, now age is integer. Previously age was float 64, now my age become integer 64. Okay, so basically I just change my data type of my field, okay, based on my requirement, right? So these are, we can change our data type in our any fields as well. Okay, so I hope you understand. Before analyzing our data, once we load our data, then how we have to read our data. Okay, how we have to check all the information about our data set, how we have to check how many missing fields we have, how we need to handle all these fields, how we need to check how duplicate value, and we need to handle all these duplicate value, how we need to change our column name, how we to how do you need to change our data type of our columns, right? So before processing our data analysis process, we have to perform all this cleaning process, okay, in our messy data set, right? Now we will see data selection and filter. Okay, so basically in real world data set, our data set is used, right? So we don't use all the data at once. So basically we usually select specific column, okay, specific column, and we filter rows based on condition. Okay, so basically this help us to focus only on the data we actually need. Okay, so as we have seen in our previous data set that in Titan data set we have age column, right? We have something like sex column, we have survive column. Okay, survive. So suppose age is like this, 30, 40, 50, 35, 60, like this. Okay, we have age like this. Sex is male, female, male, female, male. Survive 0, 1, 1, 1, 0, something like this. Okay, so suppose this is our data set. Now suppose I have to filter data, because we need to work on specific data that basically matches our condition. Okay, suppose we need to filter our data those age having greater than 30. Okay, now suppose we want to work only data those sex have is female. Okay, we have to work on the data where survive is 1, that means those have been survived. Okay, so like this we need to filter out our data, and then we need to work on our data. Okay, because in general case our data set is huge. Okay, so based on our requirement we need to filter out our data, then we need to work on that data. Okay, so this is why we need to select our data and we need to filter our data. Okay, now suppose in this data set I want to work this age data, okay, and sex data. Okay, then based on my requirement I need to filter out my data. So in order to select my specific column we have to write like this, df. Suppose this is my data set, okay, that is df. So df dot, I have to provide my column name. Okay, if it is single column, then I have to use single square bracket, and it will return series. Okay, always remember it will return series. And if I need to select multiple column, then I have to use 2 square bracket. Okay, then we have to provide column 1, column 2 like this. Okay, so basically double square bracket, and it will return data frame. Always remember, if we choose only single column, then it will return series, and if we need to select multiple column, then it will return my data frame. Okay, so now if I need to select only edge, then I have to write like this: df of edge. That's it, and it will automatically filter out this single column only. Okay, so it will only select this edge column only. Okay, now if I want to select age and sex both column altogether, then you have to write df, then you have to put double square bracket, then one is age and another is sex. Okay, now it will give a data frame, and it will filter these 2 column only. Okay, age and sex. Okay, now my row column is selected. Now I have to filter out my rows. Okay, I need to filter out my rows based on my condition. So to filter out our row, we need to use our condition. So basically, Pandas check each row and return only those rows where the condition is true. Okay, based on the condition, whatever Pandas check every rows one by one. Okay, and wherever my condition gets matched, that will picked up. Okay, that condition will picked up like this. Okay, so in order to filter out our row, we need to write like this. Suppose we need to work on age where is greater than 30. Okay, then we have to write like this: df. Then we have to start our square bracket. Then within this square bracket, I have to pass my column. Okay, that is df of age. Okay, and that has to be greater than 30. Okay, so basically, wherever my age is greater than 30, whatever this condition gets true, all the records will be picked up. Okay, so these are we can filter our data. Now suppose we want to filter our data based on a sex, and those records having female record, I want to filter out that records only. Okay, so in that case, you have to write like this: df. Then you have to provide our column name. So I want to work with sex column. Okay, now my sex column has to be female. Okay, has to be female. Or if only f is there, then I have to write only f. Okay, female. So those records, those rows will satisfy my this condition. Those records will automatically picked up. Okay, automatically picked out. So if I use my condition over here, then this row will be picked up and this row will be picked up. Okay, so these are we can filter our data. Now if we want all the data that those passengers have surveyed, that means 1. Okay, so in order to filter out that record, we have to write like this: df of df. I need to work with surveyed column, right? And that has to be 1. That has to be 1. So automatically all the 1 value, all the 1 number record will be picked up. Okay, so I hope you understand how to select our column, specific column, and how to filter our rows using condition. Okay, now let's understand this is how we can filter our data one by one with one by one condition. Right, now we can also apply multiple condition using AND or OR. Okay, we can use, this is my single condition. Now we can combine our multiple condition, okay, with AND or OR. Suppose we need to filter out some data where age is 30 and sex is female. Okay, I need to combine these 2 conditions. Okay, I need to combine these 2 conditions. So in order to do that, we have to write like this: df. Then within this square bracket, this is my first condition, that is df of age greater than 30. Okay, this is my first condition, and this is my second condition: df of sex equal to female. Okay, that means I want to filter all the rows, all the records where these two condition will match. That means those records will have age greater than 30, and at the same time those record will have to be female records only. Then those record will be picked up and that will be filtered out. Okay, and if I this is called AND. Okay, that means both condition has to be true. Okay, then only my data will be filtered out. Okay, now if I need to use OR, so suppose I need to, this is my first condition, df of suppose survived. Okay, now I want to work with those have survived, that is 1, and my second condition, this is my second condition, that is suppose df of age greater than 20, suppose. Okay, this is my second condition. Now I have to check, I want to work with those records where either this condition or this condition is true. That time I have to use OR, and to use the OR I have to use one pipe operator. Okay, I have to use one pipe operator. Then automatically pipe operator means either this condition has to be true or this condition has to be true. So wherever my records is true based on this condition or this condition, all the records will be picked up. All the records will be picked up. Okay, here in case of AND, both condition has to be true, then those record will be picked up. But in case of OR, either condition has to be true, then all the records will be picked up. Okay, these are basic difference between AND or OR, and using this and using this OR operator, we can apply multiple condition altogether to filter out our records. Okay, now next we will see, we can also filter out our data or select our data based on label. Okay, basically this is called label based selection. Okay, label based selection, and we use this label based selection using a function that is .loc. Okay, so suppose we have a small data, suppose name and marks. Okay, this is my data frame. Suppose A, B, C, 90, 80 and 70. Okay, so this is my data frame. So as this is my data frame, so automatically we have by default index 0, 1, 2. Now suppose I give my custom index, that is X, Y, Z, suppose. Okay, now let's see how .loc works. Okay, now .loc basically work like this. df, that means this is my data frame, .loc, and here I have to provide row level, comma, column level. Okay, column level. These are syntax. Okay, now for example, now if I pass df.loc and just we pass X, that means this index X. Okay, then it will give me answer as name A and marks 90, because X in the index position of X, I have name that is A and marks that is 90. So if I write just X, then it will give me output as A90. Okay, name A, marks 90. In the same way, if I write df.loc of Z, then it will give me the output as name C, marks 70. Right? Name C, marks 70. Okay. Now suppose we want from this index only name. Okay, we don't want marks, we want only name, but we need to use this index only. Then in that case, you have to write like this: df.loc, then you have to pass your index, that is X. Now I want to access only name. If I don't pass anything, if I close this my square bracket, then it will pick my name and marks both, all the column. Okay, now I want to pick up only name. Okay, that is A. Then I have to pass X. Okay, this is my column index name, comma, just I have to provide my column name. That's it, that is name. Okay, that means I am to pick up the name field only from my X index. So in name column, in X index, whatever name is there, that will be picked up. So A will be picked up. Okay. So in the same way, if I write df dot log z comma marks, that means I want to get the data from marks column but and z index. So in marks column, z index, whatever data we have, that will be picked up. That is 70. So I will get answer as 70. Okay. Now suppose this is the using only index number, we get only single value. Okay. Now suppose I want to get multiple rows. Okay, multiple rows. That means I want to access X and Z together. Okay. In that case, we have to write like this: df dot log, and we have to provide 2 square bracket. Okay. Then we have to provide X, Z, and we have to close these 2 square bracket. Okay. So it will pick up these 2 row altogether. Okay, that is X and Z. And always remember, whenever we pass only single index, then it will give answer like this, because this is a series. Okay, and whenever we need to use multiple multiple row, then we have to write like this X, Z, then it will return data frame. Okay, and the answer will be like this. Just like data frame, name, marks. Here I will pick X and Z. So A, C, marks will be 90 and 70. Okay. Now suppose you want multiple row. Okay, you want multiple row but specific column. That means name. Here I have select single index, that is single row, and I have used single column, specific column. So here I have used multiple records, multiple row, but I have to use a specific column. Okay, that means here using this formula, I get X and Z, all the record, that is name and marks together. Now I want X and Z record, but only name. Okay, only name. In that case, we have to write like this: df dot log, as this is my multiple column, so I have to provide double square bracket. Now here I have to pass my X comma Y, sorry, X comma Z. Okay, and here I have to pass my column name, that specific column that I want. Okay, that is name. Okay, now it will give me answer as, this is also data frame, so it will give me answer as name, A and C. This is X and Z. Okay, marks will not be printed here. So if I don't pass any specific column, then automatically all the records will be picked up. If I want any specific column, then I have to specify this column name. Okay, and these are for single record. These are for single record. Okay, these are for single record, and these are for multiple records. Okay, these are for multiple records. So we have seen dot loc, that is label based. Now we'll see dot iloc. Dot iloc. Okay, this is basically position based. Okay, this is basically position based. Dot loc is label based, and dot iloc is position based. So for example, this is my data frame, name and marks A, B, C, 90, 80, 70. Okay. Now my syntax is df dot ilog, and here I have to pass my row index. Okay, row index, comma column index, column index. Okay, this is my syntax. Now for example, if you write df dot ilog and pass only 0, that means the entire row of 0 position. Okay, so always remember, this is 0, this is 1, this is 2, like this for row, and this is 0 for column, this is 1 for column. Okay, like this. So if I just pass 0, then it selects entire row from entire row of 0 position. So if I write df dot ilog 0, then it will give me output as name A, because in 0 position I have name A and marks 90 and marks 90. Okay, these are single record. These are series. Okay, these were single record. Now if I pass df dot ilock 1, then it will give me output of the row of one position, that is B and 80. So name is B and marks 80. Okay. Now if I write mark, suppose I want to select only name. Okay, from this 0 position. Okay, from this 0 position, 0 row and 0 column. Then we have to write like something like this. ilock. Then we have to provide my row, that is I want this one A. So my row is 0 and my column is 0. So I have to write like this 0, 0. So it will pick up the A value, this A value. Okay. Now these are my single record. Okay, these are my single record. Now suppose I want to access multiple records. Okay, so if I want to get multiple record, then we have to write like this: df dot ilock. Then we have to provide 2 square bracket. Now here I have to pass my rows. Suppose 0 and 2. Okay, this will give me answer as this is my multiple record. So it will return data frame. So my output will be like this: name, marks. What is the 0 position of name and marks? That is A and 90. A 90, and the second position, that means this one, right? So C and 70. Okay, so we just filter out our multiple rows. Okay, multiple rows. Now suppose I have to select multiple rows but specific column. Okay, along with columns. Then we have to write like something like this: df dot ilock. Okay, now I have to provide my rows. Okay, suppose I want to take these two records, 0 and 1. Okay, 0 and 1. So we have to write like this, something like this: 0 is to 0 colon 2. Why 2? Because 2 is excluded. So always remember it is 2 minus 1. So it will go to endpoint. This is the endpoint. So endpoint minus 1. Okay, that means 2 minus 1 means 1. So it will go 0 and 1. So it will pick up this 0 and 1. Okay, and for column, suppose we want only this name column. Okay, so what is the index position of this one? That is 0, and for marks is 1. So I have to pick up only 0. So I have to write something like this: 0 is to 1, because 1 is excluded. So 1 minus 1, that means 0. So it will pick only name column. Okay, so it will give me answer as name column only, and 0, 1, 1, A and B. Okay, so these my multiple record along with column names. Okay, now I'm getting new folder. Okay, data selection and filtering. Data filter dot ipyn. Okay, now let me select my kernel. Now first of all I have to import my pandas. Import pandas as pd. Now as a data frame I want to use my same dataset. Okay, title dataset, right? So I have copied the same dataset in my same folder. Okay, now I have to read my data. Okay, df equal to pd dot read csv, and here I have to pass my file name Titanic dot csv. Okay, now I am reading my data, that is df, or let me write df dot head. Okay, so this is my data. Okay, now for selection column. Okay, Now how to select our column, any specific column, suppose passenger ID, survival, P class, name. Okay. Now suppose I want to select my name column. Okay. So in order to select my name column, we have to write like this df, and here I have to pass my column name, that is suppose name. Okay. Now if I execute, now see, I'm getting only name column. Okay. I'm getting only name column, right? So this is my single selection. Now if I want to use multiple column, if I want to get multiple column, that is suppose name, sex, and name, sex, and age. Okay. Suppose. Now for that I have to write df, then I have to put double square bracket, because this is single selection, so it will give series, and for multiple selection it will return DataFrame. So you have to provide double square bracket. Okay. Now here I have to provide name, comma, sex, comma, age. Okay. Now if I execute, now see, I'm getting only name, sex, and age column. Okay. And all this relevant data. Okay. So I have select my specific column based on my requirement. Now I have to filter my rows. Okay. Based on my condition. So suppose I want to filter all the rows where my age is greater than 30. Okay. Or my or sex is female. Suppose sex is female. Okay. Now for that I have to write something like this df of sex. Okay. I have to work on this column, right? Equal to female. Okay. So those records are met my this condition, that will be filtered out. Okay. So if I now execute, now see, this sex column is only having those record which is has female. Okay. Which is has female. Only female records will be picked up. Okay. Only female records will be filtered out. Okay. Now in the same way, if I write df of survived, okay, that equal to 1, that means those have been survived. Okay. Here you can find survived is 1, 0, 1, there is 0, there is 1. Okay. So I am to filter out all the data, those are having survived equal to 1. Okay. Now if I execute, now see, this is my survived column. All the records that is having 1, that has been filtered out. Okay. So these are, we can filter out our data based on a single condition. Okay. Now I can put multiple condition together. Okay. Now I can put multiple condition together. Suppose I want get age greater than 30 and survive equal to 1. Okay. Survive equal to 1. Those have been survived. So I have to filter out that specific records. Okay. So I have to write df, then within this parenthesis I have to put my first condition, that is df age greater than 30, and this is my second condition, df survived. Okay. Survived equal to 1. So those record will fulfill these both condition, and means that has these both condition has to be true. So those record fulfill my this both condition, those record will be filtered out. Okay. Now if I execute, now see, survived is 1. Okay. All the records survived is 1, and age is greater than 30. Age is greater than 30. So where those records fulfill this both condition together, those record will be filtered out only. Okay. Now in the same way, or works, but in case of or, my any of the condition has to be true. Any of the condition has to be true, and those record will be filtered out. Okay. Now suppose I want to picture some data where suppose my survive is 1 and my PR is greater than 100. Okay, greater than 100. Okay. Now for that I have to write df. Now this is my first condition. df of survived, that is 1, or, and I have to, for or I have to put a pipe operator. Okay, or df of fear, that has to be greater than 100. That means those record will fulfill my any of the condition, not both. Okay, whatever my records will fulfill this condition, that will be filtered out, and wherever my records will fulfill this condition, that record also will be filtered out. Okay, so any condition has to be true, then automatically that record will be filtered out. Now if I execute, now see, those records having 1, that will be picked up, and those records of fear is just a minute. Okay, because see, here fear is not greater than 100, but it is still picked out because here survivor is 1. Okay, here survive is 1, so it is only fulfilling my this condition, so it is automatically picked up, but this condition is not true. In case of or, any condition has to be true. So in this record, this condition has been true, this condition is true, so it is picked up. Whether it is true or not, it doesn't matter. Okay, now in the same way, here also my this condition, just a minute. Okay, my this condition has been true for this record also, so it has been picked up, but this condition is not true. Okay, but as this any condition has to be true, so it is already picked up. Okay, in the same way, if you find here some record is there as well, where fear is greater than 100, but survive is 0. Okay, survive is 0. That record also has been picked up because any condition has to be true. Okay, so either it is 1, then it will be picked up, or it is greater than 100, that will be picked up. Okay. Now if you have any confusion whether those record is only fulfilling this condition, that means fear is greater than 100, but survive is 0, that will be picked up or not. To check that, what you can do, you can save this data into a new data frame. Okay, new data frame. Now this become my new data frame. Okay, now new DF. Okay, now if I try to filter out my fear records where fear is greater than 100, new DS of fear, okay, greater than 100. That means from this data frame, only those record is fulfilling this condition. I am to filter out all this. Okay, now see, here fear is greater than 100 and survive is 0. Okay, that means using this condition, I have picked up all the records those are fulfilling either this condition or this condition. Okay, any of them has to be fulfilled. Okay, so this is basically difference between or and and. Okay, using and, we need to fulfill these both condition, and using or, any of the condition has to be true. Okay, next we will see about label based selection. Okay, so this is label based selection. Okay, so that means dot loc. Okay, so for that, let me create one data frame first. Okay, so for that I am writing df t. Let me check df2. Okay, Now this is my new data frame. Now I have to write pd dot data frame, right? And within this parenthesis, I have to pass my data in a dictionary format, right? So I am giving one column that is name, and within name I am passing my list of name. Okay, A, B, and C. Okay, this is my one column. Next, I will give another column that is marks. Okay, marks. Now here as well I have to pass my marks. Okay, 90, 80, 70. Okay, so these two are my column. Now I am mentioning my custom index as well. Okay, if I don't pass anything here, then all my records will have is by default index, right? 0, 1, 2, 3 and go like this. But here I need to pass, I want to pass a custom index. Okay, so I'm passing index equal to x, y and z. Okay, x, y, z. Okay, now if I try to see my data frame, okay, let me import my pandas again. Okay, import pandas as pd. Okay, now if I execute, now this is my data frame. Okay, I have name column and marks column, and these are my data, and each record is having its own custom index, that is x, y, z. Okay, now suppose I want to get this entire row. Okay, that is x, a, 90. Okay, I want to get this entire row. Then in order to get my full row, I have to write df dot loc. Okay, and here I have to pass my index, suppose x. Okay, suppose x. Now if I execute, okay, this would be df2. Now see, in x index I have name a and marks 90, so I'm getting name as a and marks equal to 90. Okay, so using my index I can get my entire row. Okay, that means I can get my full row. Okay, now if I want to get my name only. Okay, if I pass only x, then I will get name, marks and all the columns together, right? Now for example, I want name only. Okay, I want name only from this x index. Now for that I have to write df2 dot loc. Now here I have to pass my index, that is x, and within this index I want to have only name. Okay, I want to have only name. Now if I execute, now see, in x index I have only name, that is a, so I'm getting a. Okay, so if I want to get my entire row, then I have to pass only index, and if I want to get any value of a particular any specific column, then I have to pass this index comma that specific field. Okay, that specific column, right? Now suppose I want multiple record. Now see, here using this index number x, I am getting a single record, right? Now I want my multiple record. Suppose I want x and I want z, the entire record. Okay, these two record I want together. Now for that, what you have to do? We have to write df2 dot loc, and here we have to pass double square bracket. Okay, double square bracket. Why? Because whenever a single value is coming, then it returns series only. But whenever it is more than one record, then automatically it gives data frame. Okay, for that we have to pass double square. So whenever our record is more than one, then it will return data frame, and as it is returned data frame, so for that we have to pass double square bracket. Okay, always remember. Now here I want multiple rows, so for that I have to pass my multiple index one by one separated by comma. Okay, now I want x and z, so within this double square bracket, I have to pass my x and z. Okay. Now if I execute, now see, this is my data frame. Okay, and I am getting record for x index and z index. Okay. In the same way, you can pass any number of index. Okay. Now in the same way, so here we have seen from a single record we want particular any particular specific column, right? Now here as well we can do from this multiple record we want any specific records. Okay, suppose we want only marks column from these two records x and y. Okay, for that we have to, what we have to do, we have to write the same thing like df2, and within this square bracket, double square bracket, we have to pass x comma y, and here we have to pass our column name, that is marks. Okay, if I want name, then I have to pass my name. Now I want to get marks from this x and z index, so I have passed my marks column only. Okay, now if I execute, now see, from x index and z index I'm getting only marks column data. Okay, so this is how we can get a single record. This is a multiple record, and for single record we can get the data from a specific column, and from multiple data we can get a specific column data as well. Okay, now next is position based. Okay, position based selection. Okay, that is dot iloc. Okay, now here I need to create another data frame. Let me consider the same data frame. Okay, and here I am not passing my custom index. Okay, I don't record this. df3, this is df3. Okay, now if I execute, so this is my data frame. Okay, and each record is having its own index, that is 0, 1, 2. Okay, okay. Now using iloc position based index, what we have to do, what was our syntax? Iloc, and we have to pass our row index. Let me show you. df.iloc. Okay, df.iloc, and here we have to pass our row index comma column index. Right, it was our syntax, right? So first of all, if I want to get the entire row, suppose this entire row, okay, in the same manner, just like loc, if I want to get the entire record of this index, then just like loc, we have to write df.iloc, and here we have to pass our index. Okay, suppose we want 0, that means this record, this entire row A90. Okay, this entire row we want, so we have to pass our index, that is 0. Okay, here we have to pass x. In case of loc, we have to pass x. Now here in the same way we have to pass 0. Okay, this index number. Now if I execute, so this would be df3. Now see, I am getting name as A, marks as 90. Okay, in my 0 index position I have A and 90, and this is my single record, so it is returning a series. Okay, it is returning a series. Now in the same way, suppose we want from this entire record we want name only. Okay, we want name only, then we have to pass row index and column index as well. So what, this is my 0, this is my 1, this is my 2, this is my row index, and in the same way this name is my 0 column index and marks is my 1 column index. Okay, so if we want to get only A, that means if we want to get name value from this record, from this row, then we have to pass df3 dot iloc 0, 0, because we want this one. So for A, row index is 0 and column index is also 0, right? So if I pass 0, 0 and execute, now see, it is giving me A. Now in the same way, if we want to get 80, this element, Then what is my row index? That is 1. And what is my column index? That is 1. Okay. Now if I execute 1, 1, then I will get data as 80. Okay. Guys, this np.int64 means numpy integer 64. Okay. Because see, this a, b, c, these are my string value, right? This is my object. So whenever you access any object, then it will give the answer as it is. Okay. But whenever you access a value using iloc, okay, that means these are the value. Okay. So these are the value. So these are the integer value. So whenever you access a value using iloc, pandas basically returns a numpy data type. Okay. This is my numpy data type. Okay. Numpy data type. That is int int64. np.int64. Because pandas is built on the top of a numpy. Okay, pandas is built on top of a numpy. See guys, if you don't know about numpy, I have already created a 4 hours dedicated course on numpy. Just go to my channel and just watch that. Okay. So using this one by one, we are getting this record, that is 80. Okay. Now this is my single record. Now I want to get multiple records. Okay. Suppose 0 and 2 together. Okay. So for that, we have to write df3.iloc and we have to pass double square bracket. Why? Because I am accessing multiple more than one records, and whenever it gives any multiple records, it will return a data frame. And for that, we have to pass double square bracket, right? Now here we have to pass our index. Suppose we want 0 and 2. Okay, so we have to pass 0, 2. That's it. Now if I execute, now see, I am getting 0 and 2 records. Okay, name AA and name C. Okay, these 2 records, right? Now we will see how to get our rows and column together. Okay. For example, we want our this record and this record. Okay. And we want our column with name only. Okay. Then for that we have to write df3.iloc, and within this square bracket I have to pass my row index first. So I am to go from 0 to 1, right? 0 to 1. So for that I have to write 0:2. Okay, that means 0 is my starting point and 2 is my end point. Okay, 2 is my end point. Always remember, end point is always excluded. So I will go from start point to this end point minus 1. That means I will go 0 to 2 minus 1. That means 1. So I will go 0 to 1. That means I will get this one and this one. Okay. In the same way, for name, for this column, I have to write this is my row index. Now I have to provide my column index, that is comma. We have to provide 0:1. Why? I will go 0 to 1 minus 1. That means 0. So I will pick up only 0 column. That means this one. Okay. Now if I want to get 0 to the name and marks both, then what we have to do? We have to mention 0 to 2. That means 2 minus 1, 1. So I will go 0 to 2 minus 1, 1. So I will go 0 to 1. That means 0 and this is 1. Okay. So this is how you have to write. So now I want to go only name column only. Okay. Now if I execute, now see, I am getting 0 and 1. These 2 records 0 and 1 row wise, and column wise only name. Okay. Only name. Right. So this is how we can do position based selection. Okay. So guys, I hope you understand what is label based selection, what is position based selection, and what is the difference between them, and how to select single records, multiple records, single records with columns, multiple record with columns in both case, for LOC and .IOLOC, right? So guys, you create your own data frame with different values and do hands-on practice as much as possible so that you can get more clarity on LOC and IOLOC. Okay. Now we'll see data manipulation. Okay, data manipulation. So basically data manipulation means modifying or transformation. Okay, so data manipulation means modifying or transformation of your data. Okay, in real project we basically need to perform some operation like adding, new columns. Okay. Sometimes we need to update values. Okay. We need to apply different type of functions. We need to sort our data. Okay. Based on our different type of requirement. Okay. So these are the very much important step in data workflow. Okay. Before data analysis. Okay. So we need to perform this type of operation before data analysis, right? Now, how we can perform all this type of operation? Suppose in our data set, okay, we have first name and we have another column that is last name. Okay. Suppose A, B, C, X, Y, Z. Now, whenever we need to perform this type of data analysis, sometimes we require a full name. Okay, a full name, not first name or last name individually. We want full name. Then we have to combine these two fields. Okay. Then we have to write, we have to create a new field, we have to create a new column, then we have to fill up our data like this: A, X, B, Y, C, Z. So basically we need to create a new column, then we have to combine our data. Okay. Sometimes suppose we have a column like age. Okay. Now age is suppose 20, 30, 15, 17, 20. Okay, like this. Now based on our requirement, project requirement, we have to create one column of category. Okay, column of category. Those are greater than 18, that will be adult. Okay, and less than 18, that will be child. Okay, something like this. Now for that we have to create a new column, then you have to provide our one condition using some different type of function. Okay, now this will be categorized as adult, right? This would be again adult, this would be child, this would be child, and this would be adult. Okay, so basically we are modifying our data, or we are creating your data or our new data, we are creating our new column based on our project requirement. Okay, so to perform this type of modification and transformation is called data manipulation. Okay, data manipulation. So this is very much important, because we need to definitely need to perform this data manipulation because before data analysis. Okay, so in our practical we'll take our original data set, that is Titanic data set, and we'll perform a different type of data manipulation operation on this data set. Okay, so basically we perform new column creation. Okay, modifying or updating values on our data set, right, and many more. So we'll see everything one by one. Okay, so I'm creating new folder, that is data manipulation. Okay, now here I'm creating one file, data manipulation .ipyn. Okay, now let me select my kernel. Okay, so as we will work on our real dataset, so let me copy that dataset in this folder. So I have copied the same Titanic file in my this folder. So for that, first of all I have to import my pandas, right? Import pandas as pd. Now I have to read my data, right? I need to read my data set. So for that I am creating my data frame, that is df pd dot read csv, as this is my csv file, and here I have to pass my file name, right? Titanic.csv. Now df dot head. So this is my entire data set. Okay, and this is my top 5 records, right? Now I need to modify something. I need to manipulate my data. Okay, so first of all I need to add constant column. Okay, constant column. So let me write adding constant column. Okay, constant column means I want to create a new column. Okay, I want to create a new column. That column will have a fixed value in each records. Okay, fixed value. Now for that, for example, I want to create a one column that is country. Okay, I want to create a country column and all the values of country in each records, in each row, my country country value will be UK. Okay. Now for that I have to write df. Now here I have to pass my new column name. Okay, whatever column name I want to keep. Suppose I want to keep country. Okay, country. Now I just need to pass my value. Suppose UK. That's it. Now if I execute my df dot head, now see here I don't have any column name as country, right? Now I have added a new column that is country and I have passed my UK value to each records. Okay. Now if I execute, now see I am getting a new column in my dataset that is country and all the record is same, that is UK. Okay, all the records is UK, right? So this is called constant column. This is how you can create any column that will have a constant value. Okay, so this is called constant column. Now let's create calculated column. Okay, calculated column. Okay, calculated column means I want to create a new column and want to add multiple columns. Okay, now for example here I have this SIB means sibling spouse. So these are the number of sibling or spouse, and this is parent child. So these are the number of parents or child. Okay, so that means these are the family size. Okay, these are the family size. So I want to create a new column of family size and I want to add these both records. Okay, these both records. So for that I have to, what I have to do, we have to write df, then again as it is I have to write my new column name that is family size. Okay, I want to give a new column name that is family size, and here I have to add my two column that is df, sorry this would be Python. Okay, df, and I want to add sibling spouse, that means this one, okay, plus df of this one. Okay, this one. Now if I try to see df dot head, now see I am getting a new column. I'm getting a new column that is family size. Okay, and this family size is basically adding these two records. See 1 plus 0, that means 1, 1 plus 0 1, 0 plus 0 0, 1 plus 1 0 1, 0 plus 0 equal to 0. Okay, so basically I'm adding these two column, and creating a new column. Okay, so this is called calculated column. Okay, now I want to create suppose new column based on condition. Okay, based on condition. That means suppose in this age column I want to, using this age column I want to create a new column where if age is less than 18, then that will be marked as true and rest will be false. Okay, that means I want to create a new column that is child. Okay, and those are less than 18, that will be true, that means child, and those are greater than 18, that will be false, that means not child. Okay, so for that I have to write df, and here I have to pass my new column name. Okay, that means is child. Okay, now I have to put my condition on which column I want to put my condition, that is age column, right? That is age column. Now my condition is age less than 18. If age is less than 18, then it is child, that means it will show as true, rest will be show as false. Okay, now if I show df and execute, now see, I am having a new column, that is child. Okay, now age is 22, so it is false. 38, so it is false. 26 false. 35 false, like this. Okay, like this. So if you try to find out, okay, if any age is less than 18, then definitely that will be marked as true. Okay, so this is how we can create a new column using my condition. Okay, using any type of condition you can create any column. Okay, now let's see how to update our values. Okay, update values. Okay, now for example, here in this first record, the age is 22. Okay, the person is having age is 22. Now I want to update my age. Okay, I want to modify this age as 25. Okay, so let's see how we can do that. Now for that we have to write df dot loc, because this is level based. I have already shown you how loc works. Okay, so this is level based, so I want to access this label, then I want to modify my record. Okay, so I have to use my loc function. So within this I have to pass which index I want to modify, that is 0 index, right? 0 index. Now for that I have to pass 0. Okay, and in which column I want to modify my value, that is age column. Okay, that means in 0th index record, that means 0 index record, I want to modify the value of age column. Okay, now equal to, I have to pass my data which want to give, suppose 25. Okay, now if I execute df.head, now see, it's become 25. Okay, this is my 0th index value and age is 25. So that means I have updated my age. Okay, initially it was 22, now it is updated as 25. Okay, now update value using condition. Okay, using condition. Now for example, I want to create one new column. Okay, that is category, and I want to apply a condition that those is age is less than 18, those will be categorized as child. Okay, and those are greater than 18, those will be categorized as adult. Okay, so see one by one. Now I have to write df dot loc, because again I have to access using my label. Okay, now here I have to access my column, that is df of age. Okay, df of age less than 18. Okay, this is my condition. My condition is my age is less than 18. Then I have to provide my new column name, that is category. Okay, using this lock function I am accessing my age, and those record are less than 18. I am creating a new category column, and that will be filled up by new value, that is child. Okay, that means those record in age column is less than 18, those will be filled out as child, and my new column name will be category. Okay, now if I execute df dot head and execute, now see, I am having one new category. Okay, new column, that is category, and age is 25, so it is showing none, because I have only put a single condition that those are less than 18, that will be printed as child, else will be printed as none. Okay, now if I put the same condition like this, those those record is greater than 18, that will be categorized as adult. Okay. Now if I execute, now see, now see, now this become adult. Okay, nan got replaced by adult. Okay, because age is greater than 18. Okay, so all are adult. Okay, here I have used my single condition at once. Okay, this is my first condition, this is my second condition. So I'm using my condition, single condition in each time. Now we can combine these two condition together. Okay, we can combine. Now for that, what you have to do? We have to import numpy. Okay, you have to import numpy, because in numpy there is a inbuilt function that is where. Okay, using where in numpy dot where we can combine our result. Okay, so for that we have to import numpy as np. Now I have to write df. Now I have to provide my new column name. Suppose I'm not giving category because category is already there, so I'm just giving cat. Okay, and here I have to pass np dot where. Okay, np dot where, and within this parenthesis I have to provide my column name, that is df of age. Okay, df of age. Now here I have to provide df of age is less than 18. Then that means if, okay, this is my if condition, just like if condition. Okay, if age is less than 18, then I want to categorize is as child. Okay, else I want to provide as adult. Okay, you understand? I am creating my new column, that is cat, and here using this mp dot where I am just passing a condition. Okay, if my age is less than 18, then the value will be child, else our value would be adult. Okay, now if I execute df dot head, and you can see I'm getting a new column, that is cat, and this is my adult, because my age is less than 18, so it's become adult. Okay, so these both result are same. Okay, so if you want to combine your multiple condition at once, then you have to use numpy. Okay, numpy dot where clause. Fine. Now just like np dot where, if you don't want to use np dot where, there is another option, that is lambda using lambda function and dot apply function. Okay, using dot apply function and using lambda function, you can also combine these two conditions together. Okay, but it slower than np dot where. Okay, np dot where is faster, but if you use dot apply function with lambda function, then that is little slow. Okay, so I'm just showing how to use dot apply function as well. Okay, so this is dot apply function. Okay, now I'm taking same example. Okay, this one. Okay, I'm taking same example. So I have to write, first of all I have to write df, and here I have to pass my new column name, suppose cat2. Okay, I'm giving a new column name, is cat2. Here first of all I have to pass my column on which I want to use my condition. Okay, that is df dot age, df of age. Okay, now on this column I want to apply, that means I need to use dot apply function. I want to apply on df of age column. Okay, now within this apply function I have to pass a single line function, that is called lambda function. Okay, a single line function is called lambda function. So I have to provide a lambda function, lambda x. Okay, lambda x, and here I have to provide child. If my x is less than 18, else adult. Okay, that means my lambda function, I'm just taking a variable that is x. Okay, now if x less than 18, then it will be considered as child, else it will be considered as adult. Okay, so these are function, and whenever you write any function in a single line, that is called lambda function. Okay, so basically I'm just applying the same condition like this using dot apply function. Okay, now if I execute df dot head, now see, you will get same answer. You will get same answer. Okay, cat2, this is my new column cat2, and you are getting same answer. Okay, so these three are same. Here I am using my all condition one by one. Here I am using my all condition together using numpy, and here I am using all my condition together using dot apply function. Okay, fine. So I hope you understand. Once you get your data set, then based on your requirement, how to manipulate your data, how to add new columns with different type of techniques, how to modify your values with different type of techniques, right? So this is basically modification and transformation of your data set before data analysis. Okay, and remember, this is very crucial step of data analysis, right? Next, we will see data combining. Okay, data combining. Basically, in your project, whenever you get your data set, so most of the time in real world case scenario I'm talking about, most of the time your data will be in multiple files. Okay, in multiple files. Okay, so once you get your data, then basically you have to concatenate. Okay, you have to concatenate. You have to concatenate all the files. Basically, that is called stacking your data. Okay, stacking data. Okay, so you stack your data either in vertically or horizontally. Okay, so you can concatenate your data. You can merge your data. Okay, basically join. If you know SQL, then you must be knowing about join, how join works. Okay, so basically join our data based on common column. Okay, common column, right? And as well as you can join your data. Okay, similar to merge, but difference is it index based. Okay, merge is column based, join is index based. Okay, so for your project, whenever you get your data is basically usually stored in multiple files. So we need to combine them. Okay, we need to combine them to get the complete information. Okay, so basically pandas provide different type of function like concatenation, merge, joins, all these type of function to perform this type of operation. Okay, now I'm creating new folder, data combining. This is my file, data combine .ipynd. This is my kernel. So I'm keeping my same data set. Okay, so I kept my file in this folder. Now I have to import my pandas. Import pandas as pd. Okay, now I have to read my file, ef equal to pd dot read csv titanic dot csv. Now my df dot head. Okay, now first of all I want to perform concatenation. Okay, concatenation. Okay, this is vertical concatenation. Okay, let me perform first vertical concatenation. Now I have to create my data frame. Okay, now suppose I want to pick uh, top 5. Okay, I want to create two different data frame. Okay, from this data set I want to create two different data frame. One data frame is first 5 records, and another data frame is 5 to 10 records. Okay, next 5 records. So for that I have to write df1. This is my first data frame. Okay, so I have to pick using iloc because this is my index based. Okay, so now here I have to pass colon 5. That means my starting position is 0. I have mentioned nothing in start position. That means it will start from very beginning. That means 0. Okay, and it will go up to 5. But here 5 is excluding, so it will go up to 4. Okay, so it will pick these 5 records. Okay, so this is my first data frame. Now in my second data frame, I want to pick iloc from fifth index. Okay, this is my fourth index. So after this fourth index, I want to pick from 5 to 9. Okay, so for that I have to write 5 because start position is my 5 and my last position is 10 because I want to go till 9. So it will exclude. So 10 minus 1, that means 9. Okay, so these two are my data frame. Okay, now using this two data frame, I am creating one new data frame. Okay, new df, and here I want to concatenate these two data frame together. Okay, so for that I have to use pd.concat. There is an inbuilt function that is concat. Okay, pd.concat, and within this parenthesis I have to pass my df1 comma df2. That's it. Okay, now if I see my new df and execute, now see, this is my top 9 record because I mentioned 0 to 5, that means 0 to 4, 0, 1, 2, 3, 4 up to this, and here I mentioned 5 to 10, that means 5 to 9. See, 5, 6, 7, 8, 9. Okay, so this is my entire data set. This is my df1. I have created my df1 data set from my main data set. I am creating another data frame from my main data set. Then I am concatenating these two data frame and creating a new data frame. Okay, so this is my new data frame, right? So this is my concatenation, and this is vertical concatenation. Okay, this is basically, see, these are record, these two record. This is my first data frame, and this is my second data frame. So it gets stacked vertically. Okay, it gets stacked vertically. So this is why it is called vertical concatenation. Okay, now horizontal concatenation. Okay, that means my data will be stacked horizontally. Okay, here my data got stacked vertically. Now I want to stack my data horizontally. Okay, so this is called horizontal concatenation. Now for that I have to write df new df2. Okay, now I have to again write pd dot concat, and again I have to pass my two data frame till df1 comma df2, right? Now see, now as I want to concatenate, I want to stack my two data frame in horizontally, so I have to provide here axis equal to 1. Okay, this is by default. If you don't provide anything, then automatically by default it will stack vertically. Okay, it will concatenate vertically. Okay, but if you want to stack horizontally, then specifically you have to mention this one, axis equal to 0. Okay, here this is axis equal to 0. This is by default, but when you want to concatenate horizontally, then you have to provide axis equal to 1. Okay, now if I execute df2, new df2, okay, and execute. Now see. Now see. See, you can write, see here, 10 rows, 24 column. Okay, 24 column. Actually, in my data set, it was 12 column. If you count, it is 12 column. I have 12 column. But as my two data frame got stacked horizontally, so it's become 24 columns. Okay. And if you see, the passenger ID to here, this is my one data frame. And from here, passenger ID is not visible. Okay. Just a minute. Okay. Here, passenger ID is not visible. It is hiding over here. But you can see P class. Okay, passenger ID and survived. These both column has been hidden here. Okay. So from you can see P class, name, sex, age, sibling, everything is coming over here. Okay. So this is my first 12 column and this is my second 12 column. Okay. So my two data frame got stacked horizontally. So the same column got repeated twice. Okay. And automatically my column becomes 24. Okay. So this is how you can concatenate, you can stack your data horizontally. Okay. Fine. Now let's see about merger. Okay. Merger. So merge. Okay. Now see, merge is used to combine data sets. Okay. Combine data set based on a common column. Always remember, merge is used to combine data set based on a common column. It works just like SQL joins. Okay. And is very important in real world analysis. Okay. Data analysis. Now, for example, I'm creating one another data frame. Okay. Suppose extra, and I'm creating pd dot data frame, and here I'm creating my data, suppose passenger ID. Okay. I want to keep one common column, that is passenger ID. Okay. As I want to perform merge, so one common column has to be there. Okay. So I'm creating new data frame, and here I'm keeping the same one common column. Okay. Passenger ID. Now this is my list 1, 2, 3. Okay. And here I'm creating another column, that is new column. Okay. That is VIP. And here I'm passing yes, no, yes. Okay. So this is my extra data frame. Okay. Extra data. Okay. Fine. Now first see inner merger. Okay. Inner merge. Okay. Inner merge. Now for that I have to write, suppose merged. Okay. Inner merged df. Okay. So I have to write pd dot, there is another inbuilt function, that is merge. Okay. Merge. This is inbuilt function. So you have to write pd dot merge, and here you have to pass your first data frame, comma, second data frame. Okay. And here you have to pass your common column that is present in both data set. Okay. These both data sets. So what is the common column? That is, you have to provide on. Okay. On. Then you have to provide your common column name, that is passenger ID. Okay. That means using this p dot merger, I am merging this df data frame and extra data frame on passenger ID, because in both data frame my passenger ID is column. Okay. Fine. Now if I write inner merge df and execute, now see, only matching rows. Okay. Only matching rows from the database is coming out, because inner merger means only common matching fields. Okay. Now for my first, that is df. Okay. My df, that is This is my DF. So here my 1, 2, 3. These are my records 1, 2, 3. Now in my extra DF also I have 1, 2, 3. So only this 1, 2, 3, these 3 record will be picked up. Okay. So only matching columns, only matching records will be picked up in case of inner join. Okay. I'm just writing here. Only matching rows. Okay. So these 3 are my matching rows. Okay. So it will be picked up. Okay. Now next is left join. Okay. Left join. Right. Let me write. Left join means all left data. Okay. All left data plus matching right data. Okay. Right other data. Okay. So now let me write left merged df. Okay. Again I have to write pd.merge. Okay. Now here I have to write my left data frame, then my second data frame, that is right data frame. Okay. I want to join on passenger ID. Okay. This is my common column. So I have to join using this common column, that is passenger ID. And here I have to pass how. How means how I want to join. So I have to pass left. That means I want to use left join. Okay. I want to use left join. Now if I execute left merge and execute, okay, let me write dot head. Okay. Or dot 10, top 10 records. Okay. Now see, I'm getting all the records. I'm getting all the records from my DF main data frame. Okay, I'm getting all the records, and along with it, I'm getting matching right other record. That means in extra, I have only other matching record. That means VIP. I have only other data means VIP. Now see, I'm getting this VIP column as well. Sorry, this one column VIP column. Okay, so I'm getting till here till embarked. I'm getting all the data from my left table. Okay, left data frame, that is GF. And from right table I'm getting only matching data, matching other data. That means I have only VIP data, so I'm getting this one. So I have only 3 data, that is 0 1 2 3. So yes, no, yes, and rest are none, because these are blank. Okay, these are blank, so it is showing as none. Okay, so this is basically left join. Okay, now let's see outer join. Okay, that basically all data from both table. Okay, all data from both table. Now I'm writing outer merged df. Okay, now I have to write pd.merge. Okay, pd.merge. Here I have to pass my first data frame, that is left data frame, that is df. Then second data frame, that is extra. I want to merge on the basis of this common column, that is passenger ID. Okay, and how I want to join? That is outer. Okay, now if I mention outer merge data, now see, all data from both table. Okay, all data from both table. This is my first table, and this was second table, passenger ID and VIP. Okay, so all data from both table, it is basically outer join. Okay, so always remember, in inner join only matching data picked up, Okay, only matching data from both table. Only matching data from both table. Okay, that will be shown in case of left join. All the data from left table, all the data from left table, and only matching other data from right table. Okay, and for outer join, all the matching, all the data from both, not matching all the data. Okay, either it is matched or not matched, it doesn't matter. All the data from both table will be picked up. Okay, in the same way we have another join, that is right join. Okay, right join, that means all data from right plus matching from left. Okay, now if I take same example, so syntax is same. Okay, syntax is same. So this would be right and here this is my left, this is my right, and I want to join using passenger ID, and here I need to pass right. Okay, and to perform right join. Now if I execute, now see, I have only 3 records in my right data, that means data set, that is extra. Okay, I have only 3 data, so all the data from 3 is coming, and only matching data, because 1 to 3 gets matched. Okay, so I am getting only 3 data, because all data from left table, right table, that means from extra table, and matching from left table. Okay, so in my right table I have only 3 records, so I'm getting 3 records. Okay, so next is join. Okay, so join is also works same as merge. Okay, but the difference is merge works on column, but join works on index. Okay, so for that we have to create our uh, common column as a index. Okay, or as a index. So we have to write like something like this: df1 equal to df dot set index. Okay, df dot set index, and here I want to create my passenger ID. Okay, passenger ID, this column, as my index. Okay, so I'm creating my data frame. Okay, here I want to create my passenger ID as index. Okay, now in the same way I'm creating my extra data frame as well. So extra dot set index, and here I have to pass my passenger ID. Okay, so this passenger ID, this column is no longer column for my this both data set. Okay, it's become a index. Okay, it's become index for my this both data set. Okay, now I have to perform my join operation. Okay, so join df equal to df1 dot join, and here I am passing my extra. That means I am joining my df1 and extra, both data frame. Okay, so it basically combines this both data set. Okay, based on index. Okay, based on index, and always remember, by default the joining is left join. Okay, if I write join df, okay, now if I execute, now see, this passenger ID is no longer a column, it has become my index. Okay, So basically it combines my two data, okay, that is df and extra. These might based on the index, okay. Whose passenger ID becomes my index for both data, and based on this index they have combined together, okay. And as this is my left join, so all the data from df1, okay, all the data from df1 is coming out, and all the matching data from my right, that is extra, okay. So I have only 3 data in my extra, so it is coming out, it is matching, so all these are data, okay. So I hope you understand. Whenever in our real world scenario, whenever we get our data set from multiple source or multiple files, then how we can combine all our data, okay, how we can join our data, how we can merge our data together to get a final data set, okay. Next we will see about group by, okay, group by and aggregation, okay. So basically what is group by? What is group by? See, group by is basically splitting data into groups, okay. Splitting data into groups, okay. Then we need to apply different type of operation, okay, like sum, mean, okay, max, all these things. So basically group by is used to divide our data into groups based on column, okay. Always remember, based on column. So basically splitting data into groups based on column, okay. Then we apply function like average, sum, count, mean, max, everything, right. So splitting data into groups is our group by, and to perform this type of function, this type of operation, like sum, mean, max, okay. So all these are called aggregation function, okay. You understand? So this is my group by. Splitting data into groups is called group by, and to perform this type of function, that is called aggregation function, okay. Now for example, we have a data frame. Suppose we have passenger class, okay, and we have another column, that's fare, okay. Now for example, this is my first class, second class, third class, then again second class, third class, then another first class, okay. Now this is suppose 10, 20, 30, 40, 50, 60. So all these are fare, okay. Now my aim is to find out what is the sum of fare, okay, of each passenger class. That means I want to find out the sum of first class, the sum of second class, and the sum of third class, okay. That means here I want to find out my first class is this one 10 and this one 60, so sum is 70. In for second class, that is 20, and this is 40, that means 60. And for third class we have 30 and we have 50, that means 80, okay. So this is our aim to find out, okay. In the same way we can find out the mean, that means average, okay. We can find out the average of each class, okay, average of each class. In the same way we can find what is the minimum value, what is the maximum value, what is the count, all these things, right. So this is how we basically group our data, okay. We basically group our data, and on top of that we apply this aggregation function, okay, different type of aggregation function to find out our desired result, okay. Now in order to create our group and then perform any kind of aggregation function, what we have to do, suppose we want to perform this operation, okay. So I want to group my data in different class, that is first, second, third class, and I want to get the fare, sum of fare, okay, for each class, okay. So for that, suppose this is my data frame, okay, this is my df data frame. So I have to write df dot group by, okay, df dot group by. Then in which column I want to create my group, that is passenger class, right. Now here within this square bracket I have to pass my column, that is fare, of which I want to get my sum. That means dot sum. Understand? So I have to write my DataFrame dot group by. Then I want to pass my column name on which I want to create my group, and within this square bracket I have to pass my column name on which I want to perform my aggregation function, that is dot sum or dot min, like this. Okay. Now if I execute this one, then I will get like this: first, second, third, and I will get 70, 60, 80. Okay. Now if I perform some, I want to get the mean value. Okay, that means average value. Then we have to write like this: group by. Then I have to pass my column on which I want to create my group, that is P class. Then I have to pass my column on which I want to apply my aggregation function, that is sphere, right? Then I want to get mean value. I want to get mean value, right? So I will get first, second, third, and what is the mean value of it? So sum is 70, and we have 2 first, so 2. We have 2 first, 2 second, 2 third, right? So we have to divide all my sum, divide by 2. So this is 70. So I will get mean as 35. For second, I will get mean as 30. And for third, I will get mean as 40. Okay, understand? So this is how we can group our any column, any single column, and we can apply any kind of aggregation function on a single column. Okay. Now next, we will see multiple aggregation. Okay. Multiple aggregation. That means here we have performed a single aggregation, that is either sum or mean, and in multiple aggregation we can perform this type of aggregation function at once. Okay, multiple aggregation function at once. So basically we can apply multiple calculation at once using the AGG. Okay, using the AGG function. Okay, that is aggregate function, which makes analysis more powerful. Okay, so for example, I want to get my sum, mean together. That means I have to perform this same one. Okay, I want to book my passenger class, and I want to perform my aggregate function on my fare column, but I want to perform my multiple aggregation function at once. That is sum, mean, everything together. Okay, so for that I have to write df dot group by. Okay, then I have to pass my column on which I want to create my group. Then I have to pass my column on which I want to apply my aggregate function, that is sphere. Okay. Now I have to write dot AGG. Okay. That means aggregate function. And within this parenthesis, within the parenthesis, I have to pass my list of operation. So for that, I have to start with a square bracket, because I have to pass all the operation one by one as a list form. So I have to pass my square bracket. Then I need to pass, suppose, sum, comma, mean, and so on. Okay. Then I have to close my square bracket and close my parenthesis. So what happened? When we execute this code, then we can create our group on this P class, and after grouping all my data, that is first, second, third, on my fare column, I will perform sum and mean together. Okay, I am performing sum and mean aggregation function together with on my fare column on the basis of this group. Okay, so I will get my output as P class. Okay, that is first, second, third, and here I will get sum and another column, that is mean. Okay, for sum I will get 70, 60, 80, and for mean I will get 35, 30, 40. Okay, so this is how we can apply our multiple aggregation function together on a column based on our group. Okay, next we'll see group by multiple columns. Okay, multiple columns. That means here we have created our group on single column, that is passenger class. So here we will apply our grouping on multiple column. Okay, so for example, these is our data. suppose we have another column, suppose sex. Okay, this is male, female, male, female, male, female. Okay, now I want to perform my group by on p class and sex together. Okay, so how do we do that? For that, we have to write df dot group by. Okay, and here as previously I just within this parenthesis I just pass my single column, right? As this is my multiple column, okay, this is my multiple column, so I have to pass everything as a list. Okay, so for that I have to within this parenthesis I have to pass my square bracket, and here I have to pass all my column name one by one. First one is p class, comma, second one is sales. Okay, then we have to apply, then we have to write our column name on which I want to perform my aggregation function. Okay, that is fair. And here I have to pass my aggregation function. Suppose I want to get mean. Okay, I want to get mean. Okay, so I will get answer as passenger class. Okay, and sex, and these are our result. It is mean. Okay, so for first class I will have female and male. For second passenger class I will have female, male, and for third class I will have female, male. Okay, so here I will get the mean average of female of first class. I will get average of female of first class. Okay, here I will get average of male, average pair of male in first class. Okay, in the same way here I will get the average of pair on female of second class. These for male of second class. This is again the average of pair of female in third class and male in third class. Okay, so accordingly I will get all my answer. So these are we can perform multiple column group by. Okay, so multiple column group by. Okay, so next is reset index. Okay, reset index. So basically what happens after using group by, okay, after using group by, the result may have index based structure. So whatever result we are getting here also we have is own index. Okay, 0, 1, 2 like this. So after using group by, the result also having its own index based structure. Okay, so we can use reset underscore index function. Okay, to convert it back to normal table. So whenever we use reset.index, then automatically all my data will have it basically back to its normal table index. Okay, so to perform my index reset index, what we have to do, we have to just write ds dot group by. Okay, everything is same. Now here suppose p class, I want to group on p class and I want to apply my aggregation function on fiat. Okay, now I am to perform mean aggregation function. Okay, now after that we have to put till now we have seen everything. Okay, up to dot mean. Now to reset our index, what we have to do, we have to just put dot reset underscore index. That's it. Okay, just putting dot reset underscore index function, it automatically convert it back to the normal table index. Okay, now next is sorting group data. Okay, sorting group data, that means here when we perform this operation, okay, either this operation, you can consider this operation or this operation, anything. Suppose this I'm considering this operation. Okay, here I am grouping all my passenger class, that is first, second, third, and then I just try to find out my mean. Okay, now if I just run this code, then it will give like this. Okay, now if I want to sort my answer, either in ascending or descending order, then we have to use sorting group. Okay, so if we take the same example, okay, df dot group by, p class pair dot mean. Okay, now if I perform this only, then I will get first, second, third. This is 35, 30 and 40. Now if I want to sort my value in descending order, okay, sort my value in descending order, then what you have to do, you have to just pass dot sort values, okay, and here I have to pass ascending equal to false. Ascending equal to false means descending. If you pass ascending equal to true, then that means ascending order. Okay. Now if I execute this one, then instead of this result, I will get 40. First one is 40, then 35, then 30. That means this would be third, this would be first, and this is second. So if I execute this one, I will get my answer is like this. Okay. So that means I am sorting my value after finding out the aggregation function, after performing my aggregate function. So after finding out my mean of each group, I want to sort my that value. I want to sort my this entire value in descending order. That is why I just pass sort dot values and I just pass ascending into false. That means descending. If I want to pass it in ascending, then I have to pass ascending into true. Okay. So automatically it will sort my values is ascending order or descending order accordingly. Okay. So this is how we can sort our group data, right? So I'm creating new folder. That is grouping and aggregation. Okay. So grouping.ipyn. Okay. This is my file. Now I need to use my same data set. So I have copied my Genalytiq data set in this folder. Okay. Now I'm importing my pandas. Import pandas as pd. Now I'm creating my data frame. pd dot read csv Titanic csv. Okay. df dot head. So this is my data set. Okay. Now I want to group my data on sex. Okay. So I want to group my data as male and female. And on top of that, I want to perform a mean of age. Okay. So basically I want to get what is the average age of male and what is the average age of female. Okay. So for that I have to group my sex in male and female. Then I have to perform a mean on my sex column, right? So for that I have to write df dot group by. Here I have to pass my column on which I want to perform my grouping. Okay. So that is sex. Okay. And here I have to pass my column on which I want to perform my aggregation function. That is age. Okay. Now dot I want to perform mean. Okay. And perform mean so that I can get my average. Okay. Now if I save this one in a new variable, okay, and try to print this a. So now see, this is my female and male. So I have grouped my sex data. I have grouped my sex data in male and female, and this is the mean of age of female, and this is the mean of age of male. Okay. In the same way, we can try to find out the count of passenger ID. Okay, count of passenger ID on the group of passenger class. Okay, so I am to find out for each passenger class what is the count of passenger. Okay, what is the count of passenger. So for that I have to write, this is my second variable, so b. Okay, df dot group by, and I want to group my data on basis of passenger class, right? And I am to perform my aggregation function on passenger ID. Passenger ID, right? And my aggregation function is count. Count. Now, if I execute my B, now see, I have 3 passenger class, that is first, second, third, and for first passenger class, I have total number of passenger is 216, for second 184, and third the total number of passenger is 491. Okay. So this is how we can group our single column, and we can perform any kind of aggregation function on a single column. Okay. Now I want to perform a multiple aggregation. Okay, multiple aggregation. That means I want to perform multiple aggregation function together. So for example, if I take passenger class, okay, so I want to group my passenger class, and I want to perform aggregation function on fare. Okay, on fare. Okay, and I want to perform different type of aggregation function like mean, max. Mean means minimum. Okay, so average, maximum, minimum number, everything. So I want to group my passenger class, that is 1, 2, 3, and on top of that I want to get mean value, average value, maximum value on fare column. Okay, on fare. So for that I have to write C. This is my new variable, df dot group by. Now I have to pass my field on which I am to create my group, that is P class. Now I have to pass my column on which I am to perform my aggregation function, that is fare. Now as I need to use my aggregation function, multiple aggregation function together, so I have to use .agg function. Okay, .agg function, and within this parenthesis I have to pass my all aggregation function in a list format. Okay, so I have to put my square bracket, then I have to pass, suppose I want to perform mean, that is average. Now I want to perform maximum value. Okay, suppose I want to perform minimum value. Okay, now if I execute C, now try to understand. I am grouping my P class. I am grouping all my P class, that is 1, 2, 3. Okay, and I want to perform aggregation function on fare, and I want to find out mean, max, minimum, everything together. Okay, so that is why we need to use .agg function. Okay, here we have performed every function one by one. Okay, now here I performed .count, here .mean. So I perform this type of aggregation function one by one, and here I am performing my aggregation function together, multiple aggregation function together. Okay, now if I execute, now see, this is my passenger class 1, 2, 3, and for first passenger class the mean value is this, the maximum value is this, and minimum value is this. For in the same way, for second passenger class, this is the mean value, this is the maximum value, this is the minimum value, and for third passenger class, this is the average, this is the maximum value, this is the minimum value. Okay, so this is how we can perform multiple aggregation function on a single column, and group on a single, and performing group by on a single column. Okay, now we'll see group by on multiple column. Okay, group by on multiple column. For example, I want to group my 6 column, and at the same time I want to group my passenger class column, and I want to get average value of fare. Okay, I want to get average value of fare. So basically I will group my data of 6, that is male and female, and I will again group my data in P class, that is 1, 2, 3, and on top of everything I want to get average value, average fare of each group. Okay, each group. Now to perform on that, so basically here I have performed grouping on single class. Okay, everywhere I performed grouping on single column. Now here I want to perform grouping on multiple column. Okay, so for that I have to write D equal to df dot group by, and as I want to perform my grouping on multiple column, okay, so I have to pass all the column in a list format. So I have to pass square bracket, and here I have to pass suppose 6 and P class, That means I am to perform my group by operation on sex column and passenger class column together. Okay. And I want to perform my aggregation function on fare column, right? Fare column. And as I want to get my mean value, that is average value, so I have to write dot mean. Okay. That means I want to get minimum average fare of each group, and I am creating my group on the basis of sex column and passenger class column. Okay. Now if I execute D, now see, this is my sex column. Sex column get grouped in female and male. Now for female, passenger class is 1, 2, 3, 3, and for male column, I am getting for passenger class 1, 2, 3. Okay. So this is the mean value. This is the average value of first class of female. This is the average value of second class female, and this is the average fare of third class female. Okay. In the same way, this is my average fare of first class male. This is my average fare of second class male, and this is the average of fare of third class male. Okay. So this is how we can create multiple. We can create group on multiple column and perform aggregation function. Okay. Now next we will see about reset index. Okay, reset index. So basically, whenever we use group by, whenever after using the group by, the result is basically index based structure. So this is called index based structure. Okay. So to convert it back to a normal table. Okay, like this. This is my normal table. These all are my normal table. So to convert it back to normal table, we have to use dot. Dot reset index function. Okay. So if I perform the same operation, suppose E and E. Okay. Here I need to perform I have to write just index reset index. That's it. Okay. Reset index. Now see, here I did not mention reset index, so I am not resetting my index. So this is my index based structure. Okay. Now I just mention only reset index with the same code. Okay. Now if I execute, now see, this is my index based structure. This is my table based structure. Here all my data is having its own index. Okay. So basically I'm resetting my index. Okay. I'm resetting my index. Whatever result I'm getting, I'm resetting my index to and it is basically converting it back to a normal table. Okay. So for converting this to a normal table, we need to use reset index. Okay. And at the same time, we reset our index for the result table. Okay. Next, we will see sorting our data. Okay. Sorting group data, right? That means whatever result we are getting like this, okay, like this, we want to sort our data. Okay. We want to sort our data either on ascending order or descending order. Okay. Now, for example, I want to first of all group my data, passenger data. Okay. In 1, 2, 3 in passenger class. Then I want to perform I want to get average of fare. Okay. And I want to sort that value in descending order. Okay. Now see. Now if I write F equal to DF dot group by, and I want to perform my group by on passenger class column. Passenger class. Now I am to perform my aggregation function on fare. Okay. Now I have to pass my mean because I want to get my average value. Okay. Now see, now if I execute this F, okay, then I'm getting all these things. Okay. First is 84, second is 20, 3 is 13. Okay. This is basically already in descending order. Okay. My data is already in descending order. So let's perform ascending order. Okay. Let's perform ascending order. Now this data is my in ascending order. Okay. Now let's suppose I want to sort my data in descending order. Okay. So for that we have to write dot sort values dot sort values, and here I have to pass ascending equal to true. Okay, if I need to sort my value in descending order, then I have to pass ascending equal to false. That means that will sort my value in descending order. As I want to sort my value in ascending order, so it is showing I just write ascending equal to 2. Okay, now if I execute, now see my passenger class 3 got starting from false because first value is 30, second value is 20, and third value is 84. So my mean average value, all the value gets sorted in ascending order. Okay. Now in the same way, if we want to perform the same operation on 6th column, okay, so I want to group my 6th column, okay, that is male female, and I have to get average value of pair. Okay, now first of all let me execute without sorting my data. Okay, G, and this is G. Now if A is good, now see female is 44 and male is 25. Okay, so this is also in descending order. Okay, this is also in descending order. Now I want to sort it on ascending order. Okay, so sort values ascending equal to true. Okay, ascending equal to true. Now if I execute, now see 25, 44. So it gets sorted in ascending order. Okay, so this is how you can sort your data based on your requirement, either in ascending order or descending order. If you want to sort it ascending order, then you have to pass ascending to true, and if you want to sort your value in descending order, then you have to pass the value of ascending as false. Okay, that's it. So I hope you understand how to group our data in single column or multiple column, and how to perform different type of aggregation function on top of that, and how to index, how to sort our data, how to reset our index. Okay, so this is how you can perform different type of group by function, and you can perform aggregation function on top of this on group by data. Okay. Next we have data reshaping. Okay, data reshaping. So data reshaping means changing structure of data. Okay, only changing structure of data, not value. Remember, not value. Okay, it basically only change the format only. Okay, so without changing the value, changing only structure of data is called data reshaping. Okay, for example, we have a column like this: name, math, science. Okay, A, 90, 80. So it is not in shape. Okay, it is not in shape for data analysis. Okay, so before before performing any kind of analysis on our data, we need to reshape our data based on our requirement. Okay, so if we reshape this, then we can reshape this like this. Okay, name, subject, and marks. Okay, so I will have a subject is math, this one is science, and here is 90 and here it is. So you understand, this is more structured, right? This is more structured. So this will help us to analyze our data properly. So based on our requirement, based on the data structure, we have to sometime we need to change our structure of our data without changing our value. This is called data reshaping. So pandas provide different type of function to perform our data reshaping. Okay, so first one is pivot. Okay, so pivot is used basically to convert data from long format to wide format. Okay, so basically it creates a table where values are arranged based on a row and column. Okay, this is called pivot. Next we have melt. Okay, melt. So basically, melt is used to convert our wide data. Okay, wide data to long format. Long format. Pivot is from long format to wide format. Melt is wide format to long format. Okay, and melt helps when we want to make our data more flexible for analysis and visualization. Okay. Next we have stack. Okay, stack basically used to convert columns into rows. Okay, so stack is used to convert column into rows, especially when working with multi-level data. Okay, so this type of three function Pandas provides to perform data reshaping. Okay, so I'm creating new folder, data reshaping. Okay, I'm creating new file, data reshape.ipyn. This is my kernel. Okay, so first of all, I need to import my pandas. Now I'm creating my new data frame. Okay, so for that I'm creating my data. So I have to pass all my data in a dictionary format. Okay, suppose first column is name. Now I'm passing all my data, all the values in a list format. A, B, C. Okay, A, B, and another is B. Okay, A, B, B. Okay, next column is subject. Here I am passing math, science. Okay, math, science. And third column is marks. And here I have to pass all in a list format. Right? So this is my data. Now I am getting my data frame. This is df pd dot data frame, and within this parenthesis I have to pass my data. Now if I execute df, now this is my data frame. Okay, so this is my column name, subject, marks. Okay, these are the value, and this is the index. Okay, now first perform pivot. Okay, first perform pivot. So pivot is used to convert our data from long format to wide format. Okay, always remember, from long format to wide format, and it creates a table where values are arranged based on a row and column. Okay, now if I write pivot underscore df. Okay, df dot pivot, and here I have to pass index, column, and values. Okay, now I want to create my index that is name. Okay, I want to create my name column as index. Okay, now column, I have to pass my column. I want to create my column of subject. So basically I am converting my subject column, all the data of subject as a column. Okay, and I have to pass my values, that is marks. Okay, so basically I'm converting my name as index, I'm converting my subject as column, and converting my marks as values. Okay, Now if I print pivot df, now see, my name becomes index. Okay, my name becomes index, and column is subject, that is math and science. I have created my column as subject, so this is my column subject. So math and science is become two different column. Okay, and name is index and value is marks, and these are the corresponding value. Okay, for name A, math is 90, science is 80, right? For A, math is 90 and science is 80, and for B, math is 85 and science is 88, right? So basically we have convert our data from long, okay, from long format to wide format. Okay, this is my long format, so I have converted this long format to wide format. Okay, and it creates a table. It creates this table where values are arranged based on a row and column. Okay, row and column, right? So these are we can use our private operation. Okay, now next is melt. Okay, melt. So melt is just opposite of pivot. Melt is used to convert wide data into long data. Here we have converted from our long data to wide data, right? Now in place of melt, we will convert wide data into long format. Okay, and it helps when we want to make data more flexible for analysis or visualization. Okay, now for example, if we write df underscore melt pd dot melt, okay, pd dot melt, and here I have to pass my df, that is data frame. Okay, now I have to pass my id variables, that is id var. Okay, and here I want to pass my name as a id variable. I want to pass my name. Okay, and one more value I have to pass, that is value vars. Okay, that is value variable, value vars. Okay, now here I am to pass my math and science. Okay, now if I execute df underscore melt and execute variable data frame math and science. Oh, okay, sorry, I have to pass pivot.df. Okay, pivot.df, because in df I don't have any column math or science, right? Math or science, I don't have any column name in df. In df pivot.df, in this table I have my column math and science. Okay, so I have to use pivot.df, and here I have to use reset index. Okay, reset index. Now if I execute, now see, this is the index 0 1 2 3, name A, subject math 90, name B math 85, name A science 80, and B science 88. Okay, so basically it was this was my data, it was my wide data, and I have converted it in a long data. Okay, long format. So from wide to convert from wide format to long format, we use melt. Okay, understand? From, I tell you once again, once I created my data frame, it was long format. Now using pivot, I have created a wide format. Okay, from long to wide using pivot, and using melt, I have converted this wide format again into long format. Okay, so from long to wide we use pivot, and from wide to long we use melt. Okay, next we'll see stack. Okay, stack. So basically stack is used to convert columns into rows. Okay, columns into rows, especially when working with multi-level data. So if we consider this data, okay, so we have math and science column. So using stack we can convert this column into rows. Okay, so let's see how we can do that. So we have to write, suppose this is my variable df underscore stack. Okay, now I want to convert my this table. Okay, so pivot.df table. Okay, So pivot underscore df dot stack. This would be Python. Okay. So I'm using pivot.df DataFrame, and on top of this, I am using my stack. So basically, I am converting my column into rows of this pivot underscore df DataFrame. Okay. Now, if I write df underscore stack and execute, now see, here I have math and science column. Now this two column becomes my rows. Okay. So A math 90, science 80, math for B math 85, science 88. Okay. So using stack, I basically convert my columns into rows. Okay. Now in the same way, we have another function that is unstack. Okay. Unstack means reverse of stack. Okay. So unstack is the opposite of stack. It converts low level data back into column. Okay. It using stack, we converted our column into rows. Now using unstack, we converted our rows into columns. Okay. So now if I write df underscore unstack, and we want to convert our rows into columns of this table. Okay. So df underscore stack, and here I have to perform my unstack. Okay, please also have will Python. Okay. Now I have to perform unstack. Okay. Now if I see my df underscore unstack and execute, now see, here math and science, everything was my row. Now this row becomes my column. Okay. So basically it returns to this same set. Okay. So using stack, I convert my column into rows, and using unstack, I convert my rows into columns. Okay. So I hope you understand how to use pivot, mail, stack, unstack for data reshaping. Okay. So in a nutshell, just remember, pivot used long to wide, long format to wide format. Pivot used to convert long format data into wide format data. Okay. Melt used to convert wide format data to long format data. Okay. Stack is used to convert column into rows, and unstack is used to convert rows into columns. Okay. And these techniques are used for dashboard creation, reporting, data transformation, and data visualization as well. Okay. Next, we will discuss about date and time handling. Okay. So basically, in real world data set, we often have date time information. So in our column, most of the time we have a date column. Okay. We use it to analyze trends like monthly sales, yearly sales. If we have any e-commerce data, okay, e-commerce data, then we have date column definitely. Okay. And we can try to find out our any kind of trend like monthly sales, yearly sales, all of these things. Okay. So basically, Pandas provide powerful tools to work with this date and time. Okay. So first one is converting to date time. Okay. Most of the time dates are stored in text. Okay. In our data set, most of the time this date column is basically text. Okay. Data type could be text. So we convert them into date time format using to underscore date time function. Okay. So we convert using to underscore date time function, which allows to us to perform time based operation. Okay. So syntax is pd dot to underscore date time, and here I need to pass my column. Okay. So automatically my text data converted to date time format. Okay. Once we convert our data in date time format, then we need to extract date component. Okay. Date component. So after converting to date time, we can extract different type of date component like year, month, okay, day, all these things. So this help us to in analyzing data at different time levels. Okay, so when we convert our this, suppose this is our column, so we once we convert this date column into date time format, then in order to get year, month, day, we can do like this df, because my this column is in my data frame. Okay, so df, and here I have to pass my column name dot dt dot er, dt dot er. So it will give me my er component. Okay, now in the same way, if we pass dot dt dot month, then it will give me the month component. Okay, and if we write date dot dt dot day, then it will give me the day component from the date column. Okay, from this date column, right? So after converting my column into date time format, we can extract our different type of date components like year, month, day. Okay, next we can filter our data by date. Okay, so basically we can also filter data based on date condition. Okay, based on date condition, like selecting records after a specific time, okay, or before a specific time. So like this different type of condition, date condition, we can filter our data. Okay, even we can create a date range. Okay, we can create any date range. So basically we can generate a sequence of date. We can generate a sequence of date, and for that we need to use date underscore range function. Okay, date underscore range function. So using this date underscore range function, we create a sequence of date. Okay, even we can set our date column as index. Okay, we can set our date column as index to make time based operation. Okay, even we can sort our data based on date to see trends in a proper order. So we can sort our data by date. Okay, we can sort our data by date to see change in proper order, right? So in summary, we can say in our real world data set, our date column, most of the time it is text. So we have to, first of all, we have to convert it in date time format. Then we can extract different type of date elements like year, month, day. Okay, then also we can filter our data using date. Okay, different type of date condition. We can create our date column as index. Okay, and also we can create a date range. Okay, we can create a date range based on our requirement. Okay, so these are the function is generally used to handle our date and time in our data set. Okay, so I'm creating new folder, date, time, and date. So I'm creating one file, date time date underscore time dot ipynb. Okay, so I'm selecting my kernel. Okay, now first of all I have to create a data frame with date column. Okay, with date column. So for that I have to import pandas first, pandas as pd. Now I'm creating my data. I'm creating one date column. Date column. Okay, and here I'm passing 2026 01 01. Another is 2025 02 01. Another is 2024 0301. Okay. Now I'm creating my data frame df underscore date pd dot data frame, and here I need to pass my data. Now if I print my data df underscore data, now see, I'm getting like this. Okay. Now this is my data. Now if you check data type of this date field, okay, date dot d type, okay, and execute. Now see, it is showing string data type. Okay, basically these all are string. Okay, these all are string. But if my date is string, then we cannot perform any kind of time analysis, right? So for converting my date from string to date time format, we have to convert it using to underscore date time function. Okay. Now for that we have to write df underscore date, and here I have to pass my date column. Okay, that means I'm using my date column from my this data frame. Now I'm converting my date column using pd dot to date time. Okay, using this pd dot to date time function, I'm converting my df data of date field. Okay, df underscore date of date. Okay, so basically I'm converting this column using this to underscore date time function, and again I'm storing in the same column. Okay, now if I execute, now I'm getting the same result. Now if I execute this one, now you'll see d type mb us. Okay, basically this is my it is basically converted into date time format. Okay, this data type mbus means date time data type. Okay, date plus time. Okay, here this less than is basically it is called little India. Okay, this is basically memory format. Okay, and this mb is date time type. Okay, numpy internal name, that is basically using in numpy. Okay, and this us is time unit, that is microsecond. Okay, right. So here date time is stored in microsecond position, right? So basically my date column converted to date time format. Okay, now as my date column has converted to date time format, so now we can extract different type of date element like year, month, day, everything. Okay, so for that what we have to do, we have to write df underscore date. Okay, df underscore date, and here I'm basically I'm creating a new column. Okay, that is year. Okay, year, and to extract our year from our date column, we have to write df underscore date, and we need to extract from our date column, and we need to extract year, that is dt dot year. Okay, in the same way we can create our month and day. Okay, this is for month, this is for day, and this is dt dot month, and this is dt dot day. Okay, now if I execute the same data frame, that is df dot date. Okay, now see, 3 column gets added, that is year, month and day. Okay, year, month, date, these 3 column get added, and each column is extracting its corresponding value, that is year. So 2026, month is 1, day is 1, this is for 2025. Okay, and month is 2 and date is 1, and this is for 2024, and month is 3. Okay, month is 3 and day is 1, right? So these we can extract our different type of date element from our date column. Okay, now next we see how to filter using date. Okay, now for example we want to filter all our date which is greater than 31st of January 2025. Okay. So for that we have to write df underscore date, and here I have to pass df underscore date, and here I have to pass my column name, that is date. Okay, that should be greater than 2025, that means 2025 first means January and 31st means 31st. Okay, so I want to filter all my data that is greater than 31st of January 2025. So if you see your data, so this 2024 will not be considered over here because this is less than this one. Okay, so if you consider this one, so I have 1st of February, right? 1st of February 2025. So this will be considered, and this is 2026. So this data definitely will be considered. So now if I execute, okay, square. Okay. Now see, I am getting these two records. Okay, these two records, 2026 and 2025, because these two records is greater than 31st of January 2025. Okay, so this is how you can put your condition and you can filter your data based on your requirement using date. Okay, now let's see how to create a range of dates. Okay, range of dates. Now for example, I'm creating dates. Okay, dates pd dot date range. We have to use date range. In order to create a range of date, we have to use date range function. Okay, now here I have to pass my start point. Okay, my start point. Now suppose I want to start my date range from 1st of January 2023. Okay, so for that we have to write 2023 January 1st. Okay, 1st of January 2023. Okay, and here I have to pass one period. Okay, periods is 5. 5 means periods equal to 5 means I am to get 5 dates. Okay, I am to get 5 dates. Now if I execute date, so basically using this date range I am creating my the range of dates. My starting point is 1st of January 2023 and periods equal to 5 means I am to get 5 days. Okay, now if I execute, now see I am getting 5 days, that is 1st of January, 2nd of January, 3rd of January, 4th of January and 5th of January. So I'm getting 5 dates. Okay, and if you see, data type is date time and frequency is D for D means day. Okay, because I'm getting my all element as a day. Okay, this is the first day, this is the second day, this is the third day, this is the fourth day, this is the 5th day. Okay, so this is why it is showing D. Okay, so D means day. Okay, that is one day. Now you are getting your data in 1 day interval. Okay, now for example you want to get your data in month wise, year wise, month, start of the month, end of the month, start of the year, end of the year, or 2 day in gapping of 2 day, then you can define all these things. Okay, for that we have to pass. If you don't pass anything over here, just pass your date and periods, then it will give by default in 1 day frequency. Okay, 1 day frequency. Now if you want to change anything, then you have to pass frequency. Okay, you have to pass frequency. Now if you pass 2D, okay, and execute, now see you are getting frequency of 2 day, that is 1st of Jan, now 3rd of Jan, gapping of 2, next is 5 of Jan, next 7 is Jan, and this is 9th of Jan. So the frequency is 2 day gapping. Okay, now for example I want to have data of my end of the month, so I have to pass M. Okay, M failed to parse, M is no longer. Okay, M is no longer supported. Now it is ME, month end. Okay, now if I execute, now see you are getting 3 dates of every month end, that is 31st of Jan 20 8th of February, 31st of March, 30th of April, and 31st of May. Okay, so you are getting 5 monthly date. Okay, monthly date, and all is ending date. Okay, month end date. Now, if you want to have monthly date but starting with starting date, okay, that is monthly starting date. Now if I execute, now see, you are getting monthly data, monthly date, but it is starting date. Okay, that is 1st of Jan, 1st of February, 1st of March, 1st of April, and 1st of May. Okay, in the same way, if you want to get year wise, okay, year wise, now if I pass YS, that means starting of the year. Okay, now if I execute, now see, first March of 2023, 1st March of 2024, sorry, March not, January, 1st January of 23, 1st January of 24, 1st January of 25, 1st January of 26, and 1st January of 27. Okay, in the same way, if you pass year end, okay, now see, 31st of December 2023, 31st of December of 2024, 31st of December is 2025, 31st of December of 2026, and 31st of December of 2027. Okay, likewise you can get weekly. Okay, weekly, if you want to get weekly, then W, we have to pass W and see weekly. 1st of Jan is 8th of Jan, is 15th of Jan, 21st, 2nd of Jan, and 29th of Jan. Okay, now we can, if you pass B, that is business day. Okay, business day, and if you execute, now see, 2nd of January, 2nd of January is business day, 3rd of January, 4th of January, 5th of January, 6th of January. Okay, because if you see the calendar, 1st of January 2023 was Sunday. Okay, so it was not business day, so automatically it calculates, and it gets start from 2nd of January. Okay, so this is how you can define different type of frequency based on your project requirement. Okay, wherever it is required, what type of frequency, date frequency you want, based on that you have to provide your frequency and you will get your date range. Okay, next we will see setting date as index. Okay, setting date as index. So we can set our date column as index. Okay, so for that we have to write df underscore date dot set index. Okay, set index, basically we are setting our index of this data frame. Okay, df of date, and here with this parenthesis we have to pass our column, that is date column, and here we need to pass in place equal to true. That means I want to update my modification in my data directly. Okay, I want to save my changes in my data frame directly. Okay, so now if I execute df underscore date and execute, now see, my date column becomes my index. Okay, these are my column and date is my index. So don't be confused, either date is index or column. Okay, if date is column, then it will align just beside of this column name. Okay, every column will be aligned in the same line. Okay, and as date is just below of this column line, so that means it is index. Okay, index always align just below of the column name. Okay, so basically we converted our date column as our index. Okay, now next we will see how to sort our data by date. Okay, see, these are default date is sorting by ascending order. This is January, February, March. Okay, so default is ascending order. Now if I need to sort my data in ascending order, descending order. Okay, descending order, then we have to write df underscore date dot sort index. Okay, that means I want to sort my data based using this index. Okay, using this index, and this is by default descending. Okay, by default descending, as date is by default ascending, so using this sort underscore index, we can sort our data using this function. We can sort our value in descending order. Okay, in descending order. Now if I execute, now see, it was my ascending order, January, February, March. Now when I pass sort underscore index, it gets sorted in descending order. Okay, so 1st of March, 1st of February, 1st of January. Okay, so using this sort underscore index, we can sort our data using index. Okay, using index, we can sort our data in descending order, right? So I hope you understand. Once we start our data analysis, then how to handling our date and time field. Okay, how to convert it in date time format. Then how can we extract different type of date element. Then how can we set our index. How we can create different type of date range, right? How we can filter our data based on different type of date condition. Okay, so and how we can sort our data as well. Okay, so we can see everything one by one. Okay, so I hope you understand everything. So guys, just take different type of data set from internet and try to perform this type of date time handling operation in that data set as much as possible, and try to practice as much as possible to get more clarity on this type of operation. Okay, so guys, that's it for this Pandas full course video. I hope this video helped you to understand Pandas from basic to advanced level. If you practice all this concept properly, you will be able to work with real world data confidently, right? So whatever code we have done in this entire video, I have added it in a GitHub repository, and the link is given in the video description box. So you can download the code and practice from here. If you found this video helpful, don't forget to like, share the video and subscribe to the channel for more such content. And if you have any doubt, feel free to ask in the comment. Thank you for watching, and I will see you in the next video.